in the vast dark sea between stars, silence reigns. It is a silence older than Earth, older than the sun itself, a silence broken only by the patient drift of dust and stone flung outward from the furnaces where new worlds are born. Most of these fragments wander endlessly, cold and unobserved, destined never to fall under the gaze of living eyes. Yet, every so often, one of these silent emissaries drifts close enough to touch the edge of our sun's dominion. And when it does, our telescopes, like watchmen at the gate of night, catch a glimpse of something utterly alien. 3I, Atlas, was one such glimpse. It appeared not as a blazing omen streaking across the sky, nor as a well-behaved comet faithfully circling our sun, but as a ghost, a trespasser, a stone born under a star we will never see. It came in quietly, with the faint glow of sublimating ice betraying its presence, a pale smudge against the blackness. At first, astronomers were not certain what they were seeing. To most, it was just another comet, another frozen body paying its brief visit to the sun before returning to the cold reservoir beyond Neptune, but the mathematics of its orbit whispered otherwise. Its path was wrong, its curve was not bound. Unlike the billions of comets that loop obediently around our sun in long ellipses, Atlas traced a trajectory that no familiar body should. It was not circling home, it was passing through, rushing headlong across the solar system as if it were late to a rendezvous in the dark beyond. The hyperbolic arc revealed the truth. Atlas did not belong here. It was born elsewhere, in another cradle of creation, perhaps hundreds of light years away. This revelation struck the scientific world with both wonder and unease. For most of human history, the night sky seemed eternal, unmoving, populated only by familiar stars. The planets wandered, yes, but even they kept faith with their orbits, their rhythms predictable, their dance eternal. To imagine an object arriving from another star system was once the domain of myth and speculation, not of observation, yet here it was a piece of another world, drifting into ours. The name 3I marked its place in history, the third interstellar object ever detected by human science. The first had been ʻOumuamua in 2017, a cigar-shaped enigma that tumbled silently past us before slipping away forever. The second, 2I, Borisov, in 2019, had resembled a more familiar comet, though its chemistry told of distant origins. But Atlas was something different again, fragile, volatile, unpredictable. It seemed to resist classification, as though it carried the character of a place where our physics might take on unfamiliar hues. For astronomers, its sudden presence was both gift and torment. A gift because each interstellar visitor was a rare window into a greater cosmic story. Torment because these objects never stayed. They arrived quickly, burned briefly in the sun's light, and fled just as quickly, their secrets slipping beyond reach. But imagine, for a moment, if it had not. Imagine a different fate, one in which Atlas never broke apart, never slid back into the void, never became another fleeting whisper in our catalogue of mysteries. What if, by some twist of gravitational fate, it had remained? What if this fragment of another sun had been caught, captured, tethered to the invisible threads of our solar system's great clockwork, destined to orbit here, to stay? The thought presses on the imagination with both awe and dread. For in such a fate lies not only the promise of knowledge, but the weight of a truth humanity may not yet be ready to bear, that we are not isolated, not separate, not alone in the grand design, that fragments of other skies brush against ours more often than we dare to believe, and that sometimes the universe chooses to leave us, reminders, stones born under alien suns, passing close enough for us to see, but seldom close enough for us to keep. 3I, Atlas was one such reminder, a visitor that shouldn't exist, a ghost that should never have been here, but was. And though it has gone, The imagination lingers on the unanswerable. What if it had stayed? Across the galaxy, stars are born in nurseries of dust and gas. Within these vast, turbulent clouds, gravity sculpts order from chaos. Tiny grains of ice and rock collide, clump, and grow. Some form planets, some remain as drifting comets. Others are hurled outward, victims of violent gravitational dances between young giants and newborn suns. These wanderers, set adrift in the gulfs between stars, are the cosmic exiles of creation. They carry with them the chemical fingerprints of their parent systems, whispers of alien chemistry written into their ice and stone. 3I. Atlas was one of these exiles. A fragment, small by galactic standards, yet profound in what it represented. It bore a lineage that stretched beyond the solar system, beyond even the nearest stars visible to the naked eye. Its atoms may have condensed in the disk of a star long extinguished, its chemistry forged in explosions older than Earth itself. Each molecule of water ice, each grain of dust, carried within it the silent memory of another world's beginning. The term interstellar object sounds clinical, but beneath it lies a deeper truth. These bodies are relics of stellar families we will never visit. They are evidence that the galaxy is not a set of isolated islands, but an ocean of shared debris. When astronomers detect such an object, they are not merely observing a rock. They are intercepting a message billions of years in the making, a traveler launched across unfathomable distances. Consider what it means that this fragment found its way to us. The Milky Way is immense, with hundreds of billions of stars scattered across 100,000 light-years. The void between them is staggering, yet these objects still arrive. They thread through the needle's eye of probability to fall into the tiny volume of space where human telescopes can see them. Each detection is a miracle of circumstance, a cosmic lottery win against impossible odds. And yet, perhaps it is not so rare after all. Theories suggest that trillions of such objects wander our galaxy, countless shards of alien systems cast loose during their violent youth. If so, then the solar system is not untouched. It is constantly crossed by silent visitors, most too small or too faint for us to notice. What we have seen, ʻOumuamua, Borisov, Atlas, are simply the ones large and bright enough to betray themselves. The rest slip past, ghosts in the night. Atlas, though fragile, became a symbol of this truth. Its presence told us that we are connected to a greater web of galactic exchange. Our Sun, with all its planets and comets, is not an isolated creation, but part of a dynamic system in which stars give and receive fragments of each other. A frozen body like Atlas is not merely a comet, it is a courier of chemistry, a vessel carrying the dust of stars humanity will never reach. In poetic terms, one might call it a seed. If carried far enough, if sheltered well enough, such seeds might even plant the possibility of life elsewhere. The building blocks of carbon chemistry, amino acids, complex organics all could lie dormant within the frozen shells of interstellar debris. They are cast out, scattered like pollen on the galactic wind. Sometimes they fall into barren places and remain forever silent. Sometimes, perhaps, they find fertile ground. When Atlas entered our solar system, it carried with it this unspoken possibility that we were being offered a glimpse into another cradle of life. We will never know the details. Its chemical richness was lost as the object broke apart. But the thought lingers. Had it stayed, had it survived, humanity might have placed instruments upon it, tasted its dust, and held in our hands the alien chemistry of another star's making. In its silence, Atlas also reminded us of the fragility of knowledge. These interstellar fragments pass quickly. They are visible only for months, sometimes weeks, before fading back into the abyss. To encounter one is to stand at the edge of a fleeting opportunity. To lose one is to confront the humility of science, knowing that some truths will always remain beyond reach, not for lack of effort, but because the universe does not yield them easily. Still, the significance of its existence cannot be diminished. Atlas was proof that cosmic migration is real, that stars share their debris, and that our solar system is not sealed off but open to the galaxy's constant exchange. It was a reminder that the Milky Way is alive with movement, that even the emptiest stretches of space are crossed by wanderers carrying stories older than life on Earth. And so we see Atlas for what it truly was, not just a comet, not just an icy fragment, but a page torn from another book of creation, delivered briefly into our hands before the wind carried it away again. It was a fragment from the stars, a relic of another sun, a ghost of another world, a whisper that told us we are part of a much larger story. In astronomy, discovery often begins not with a dramatic moment of revelation, but with a quiet signal buried in numbers, a faint pixel on a digital screen, a trace of light indistinguishable at first glance from background noise. The discovery of 3I, Atlas, was no different. It began in the unassuming glow of a survey telescope designed not for grandeur but for vigilance, the Asteroid Terrestrial Impact Last Alert System, or ATLAS. ATLAS is humanity's sentinel. Stationed in Hawaii, its twin telescopes sweep the heavens each night, not to study beauty or distant galaxies, but to watch for danger. Its primary mission is practical: to detect asteroids on collision courses with Earth. Every night, it records thousands of exposures of the sky, scanning systematically, comparing new frames with old, flagging the faint, moving dots that betray the presence of near-Earth objects. It was in this steady routine, this careful vigilance, that the faint glimmer of something extraordinary first appeared. In early 2020, astronomers noticed a small diffuse spot moving across successive images. At first, it looked like an ordinary comet, one of countless icy remnants that wander the solar system, flaring briefly as they approach the sunday. Its coma, a hazy shroud of sublimating ice and dust, suggested activity typical of a comet warming under solar radiation. There seemed nothing remarkable about it. But as data accumulated, the numbers began to whisper a different story. The object's orbital path was wrong. Instead of tracing an ellipse that would carry it around the Sun in some long arc, it followed a curve that opened outward, a hyperbola. This was the same unmistakable signature that had revealed the truth of ʻOumuamua 3 years earlier. A hyperbolic orbit means only one thing: the object is not bound to the sunday. It came from interstellar space, and it would return there again. The realization spread quietly at first, then with growing intensity through the community of astronomers. The designation came C/2019Y4 Atlas. Later, when its interstellar nature was confirmed, it would earn the name 3I Third Interstellar. A new chapter in human observation had opened. The people behind the discovery felt both exhilaration and frustration. To glimpse an interstellar visitor is to stand at the edge of an extraordinary opportunity, but also to feel the weight of its fleeting nature. They knew the comet would not stay long. At best, they had months to observe it, to collect data, to unravel what little they could before it slipped beyond reach. And there was another challenge. Unlike ʻOumuamua, which had passed silently without outgassing, Atlas showed signs of fragility from the start. Its brightness increased dramatically, leading some to hope for a spectacular comet, visible even to the naked eye. But brightness can be a deceptive omen. It often signals instability, fragmentation, a body falling apart under the stress of solar heating. Indeed, by late spring of 2020, Atlas disintegrated into faint dust and shards, robbing scientists of the chance for prolonged study. But in that brief window, before it faded, the discovery of Atlas ignited imaginations. For astronomers, it was proof once more that interstellar debris crosses our path, that the solar system is open to the galaxy's traffic. For poets of the cosmos, it was the image of a ghostly traveler brushing past, a messenger from a distant cradle of creation. There is something deeply human about the act of discovery. To watch the night sky, to search for faint traces of movement, is to participate in a tradition that stretches back to ancient stargazers. Yet now, our tools expand our reach beyond imagination. With instruments like Atlas, Pan-STARRS, and the Vera Rubin Observatory soon to come, we are no longer passive watchers. We are active hunters of the unknown. And in those hunts, discoveries like Atlas remind us that the cosmos is more porous, more dynamic, more alive than we once believed. For those first astronomers who saw the faint smear of Atlas on their screens, the knowledge must have carried both wonder and sorrow. Wonder at the sheer improbability of intercepting such a fragment in the immensity of the galaxy. Sorrow at knowing that this fragment, once noticed, would soon be gone again. Discovery is not always possession. Sometimes it is the recognition of a fleeting miracle, something glimpsed but never held. The story of Atlas's discovery is thus not just a story of telescopes and coordinates, but a reminder of the humility of science. We can see further than ever before, yet the universe still reminds us of our limits. We can watch as interstellar messengers pass by, but we cannot make them stay. Still, even in its brevity, Atlas expanded the horizon of human curiosity. It joined ʻOumuamua and Borisov in forming a pattern, a growing acknowledgement that interstellar visitors are not anomalies, but a natural part of cosmic life. The night sky is not a sealed dome, but a crossroads, a place where paths intersect briefly before diverging again into darkness. On the screens of astronomers in Hawaii, in those first faint detections, this truth shimmered into focus. A small smudge of light, drifting where no comet of ours should drift. An object that belonged not to us, but to the stars. And thus, with its discovery, the mystery deepened. What secrets did this fragment carry? And what would it mean if, against all probability, it had never left? In the theatre of the solar system, every body is a dancer bound by gravity's choreography. The planets trace their ellipses with solemn patience. The comets sweep long, icy arcs, returning again and again like clockwork heralds. Even asteroids, scattered and restless, obey the sun's invisible tether, circling within the rules of Newton and Einstein. To live under the sun is to accept its dominion, to bend one's path into an ellipse, no matter how wide or eccentric. But 3I, Atlas refused to obey. When astronomers charted its motion against the stars, the numbers whispered a disturbing truth. This comet was not circling home. Its orbit was not an ellipse, but a hyperbola, a curve that does not close, that does not return. Its path cut through the solar system like an arrow shot from the darkness, bound for no return. Such trajectories are rare, and in the language of celestial mechanics, they tell a story of exile. The mathematics was unforgiving. To break free of the sun's pull, an object must travel faster than the escape velocity at its distance. For Earth, that number is about 42 kilometers per second. For the solar system itself, at its edge, it is a little less, but still immense. Comets and asteroids born under our sun simply cannot sustain such speeds on their own. They remain tethered, no matter how far they roam, and yet Atlas moved with the casual momentum of something already free. It was not escaping, it was merely passing through. This revelation sent ripples of unease through the scientific community. The solar system has always been imagined as a closed family, a system where every stone, every comet, every icy body belongs to the sun's domain. Interstellar space was a void beyond, a distant elsewhere. But here was evidence that the boundary was porous, that the solar system was open to the galaxy's traffic. To see Atlas moving on such a trajectory was to be reminded of our fragility. The sky above us is not sealed. The sun's gravity well, vast though it is, cannot shield us from every stone flung across interstellar space. Atlas was harmless, but its path echoed a silent warning. Others like it may not be. Some may be larger, swifter, invisible until too late. And yet, there was also wonder. The hyperbola was not merely a mathematical oddity, it was a signature, a message written into the sky. It told us, unequivocally, that this object was not one of ours. Its birthplace lay under a foreign star, its long journey measured not in millions but in billions of years. The precision of its trajectory was a kind of cosmic autograph, proof that we were witnessing something profoundly rare, a fragment of another system, just briefly brushing ours before vanishing back into the abyss. Visualize its path, a line drawn across the solar system's plane, slicing through the orbits of planets, curving only slightly under the sun's pull, and then straightening again, bound for the dark beyond Neptune. It came in from the void, looped around the sun in a brief, dying flare, and was gone, a ghost drifting across a stage where it was never meant to perform. For those who study orbital mechanics, the trajectory of Atlas was both elegant and terrifying. Elegant because the equations of Newton and Einstein predicted it precisely. Terrifying because it forced us to confront the scale of galactic migration. If one such object had wandered into our gaze, how many countless others slip past unseen? How many stones from alien cradles sweep silently across our planetary neighborhood, leaving no trace but the faintest whisper in the night? The public, too, was captivated by the story once the news spread. Headlines called it an interstellar comet, a messenger from another star. But the details, the subtleties of its hyperbolic arc, carried a deeper resonance. This was not simply a comet, it was a reminder that our solar system is not an island fortress. It is a porous eddy in a greater galactic current. The trajectory also raised another haunting thought. If Atlas had been moving just slightly slower, if it had brushed too close to Jupiter, it might have been captured. The difference between capture and escape is delicate, measured in meters per second. In another timeline, this interstellar body might have been bound to our sun, circling endlessly, offering itself to study. Instead, its velocity condemned it to freedom. Its very path was the reason we would never truly know it. And so, the shocking trajectory of Atlas became not just a scientific fact, but a philosophical metaphor. It was proof of exile, proof of impermanence, proof that not all mysteries are meant to be solved. Some arrive only to remind us of the scale of what we cannot hold. In the end, Atlas's hyperbola was both a farewell and a warning. It came from the stars, and to the stars it would return. It would not stay, it would not yield its secrets. And in its refusal, it left us with the haunting question that lingers still. What might have been if gravity had claimed it as our own? From the beginning, 3I, Atlas resisted every attempt to be placed neatly into a category. It looked, at first, like a comet. It developed a coma, the hazy shroud of vapor and dust that forms when frozen materials sublimate under solar heat. It began to brighten as it approached the sun, just as countless comets before it had. But almost immediately, it began to misbehave. Comets are not strangers to volatility. They are fragile assemblages of ice and rock, porous and fractured, prone to sudden bursts of activity. But Atlas did not follow the rhythm of ordinary comets. Its brightness rose far too quickly, as though it were flaring with an intensity beyond expectation. Early estimates suggested it might even become a great comet, visible to the naked eye, perhaps a spectacle worthy of historical memory. Astronomers and skywatchers alike prepared for a show. Yet, as the weeks passed, the brilliance that had promised wonder betrayed its instability. Instead of becoming a luminous beacon, Atlas began to crumble. Observations revealed that its nucleus, rather than remaining intact, was breaking apart. It was as if the very structure of the comet could not withstand the stresses of its journey. Within months, it disintegrated almost completely, leaving behind only faint dust and debris. The dream of a great comet faded into a ghostly smear in the sky. This behavior puzzled scientists. Comets brighten and fade, but the drama of Atlas's rise and collapse was extreme. Why had it flared so violently? Why had it failed so catastrophically? Some suspected that it had been fragile from the beginning, a fragment torn from a larger parent body long ago. Others suggested that it carried volatile compounds, exotic ices, that vaporized explosively as it neared the sunday. Its alien origin made both possibilities plausible. To understand the strangeness, one must recall the difference between solar system comets and interstellar ones. Our comets are survivors of a familiar environment, the Kuiper belt, the Oort cloud, regions sculpted by the sun's gravity. They are old, but their chemistry is of local design. Interstellar objects like Atlas are not. They formed under conditions we can only guess at. Their ices may include compounds rare or absent here. Their structures may have been battered by untold millions of years, drifting in interstellar space, bombarded by cosmic rays, fractured by distant tidal forces, weakened by journeys we cannot trace. By the time Atlas reached our sun, it may already have been a ruin. Yet there was more. Astronomers tracking its light curve noticed irregularities, fluctuations that defied neat models. Its fragments did not simply fall away, they seemed to evaporate, to dissolve into invisibility more quickly than expected. It was as if the object carried within it a secret fragility, a design that could not survive even brief intimacy with starlight. The comparison to ʻOumuamua became inevitable. That first interstellar visitor had shocked scientists with its refusal to produce a cometary tail, even as it accelerated in ways not easily explained. Some argued that its behavior hinted at something beyond a natural object. Atlas, by contrast, did develop a coma, but its disintegration was equally baffling. One seemed too stable, the other too fragile. Together, they painted a picture of interstellar visitors as unpredictable, defiant of the rules we thought governed small bodies. In this sense, Atlas broke not only physical rules, but also intellectual ones. It resisted classification. Was it a comet, a fragment, an interstellar iceberg? Each new observation seemed to complicate, not clarify, its identity. And therein lies the heart of scientific discomfort. Nature had handed us an object that did not fit, and then had the audacity to remove it before we could answer our questions. The philosophical resonance is hard to miss. Atlas, like so many mysteries, revealed itself only in passing and denied us the satisfaction of certainty. It reminded us that science is not a steady march toward knowledge, but a dance with the unknown, often marked by losses as much as by gains. We had glimpsed something alien, but only enough to sharpen our hunger, not to feed it. Yet in breaking the rules, Atlas left behind something precious. It expanded our sense of possibility. If interstellar comets can flare and disintegrate in unexpected ways, what other behaviors might exist beyond our solar system? What else might drift among the stars, waiting to surprise us? Its collapse was not an ending but an invitation to build better instruments, to watch more carefully, to be ready for the next emissary. In the night sky of 2020, the fading smear of Atlas might have looked like failure, but in truth, it was a triumph of perspective, a reminder that the universe is not obliged to conform to our categories, a comet that broke the rules, showing us, in its brief and fragile life, that the cosmos is far stranger and far richer than we dare to assume. Before Atlas, before Borisov, there was ʻOumuamua, the first of its kind. A shard of strangeness that slipped silently into our solar system in October of 2017, leaving behind a riddle that still unsettles scientists today. ʻOumuamua's arrival was the cosmic prologue to Atlas's brief appearance. Together, they form the beginning of a new chapter in astronomy, a chapter where humanity realizes that interstellar visitors are not rare curiosities but recurring emissaries, each stranger than the last. When it was first spotted by Pan-STARRS in Hawaii, ʻOumuamua appeared as little more than a streak of light, but its orbit told the story, a hyperbola, proof that it came from outside the solar system. For the first time in history, we were witnessing a confirmed interstellar traveler. The very name chosen, ʻOumuamua, Hawaiian for scout or messenger, carried with it a sense of prophetic weight, as though it had been sent to warn or remind us of truths long forgotten. Yet what unsettled scientists most was not its trajectory, but its behavior. ʻOumuamua showed no coma, no visible tail, no outgassing of vapor, yet it moved as though something were gently pushing it. It accelerated in ways not explained by gravity alone. Comets accelerate because of sublimating gases, asteroids do not. ʻOumuamua seemed to do both and neither, defying our categories. Its shape, too, defied expectations, elongated like a cigar or flattened like a pancake, tumbling end over end. No known solar system body resembled it. Theories multiplied. Perhaps it was a fragment of a shattered planet, perhaps a hydrogen iceberg, perhaps something even more exotic. Harvard astronomer Avi Loeb courted controversy by suggesting it might be artificial, a probe, a relic of alien technology. Most scientists dismissed this idea, but the discomfort lingered. ʻOumuamua had broken the rules, and it had done so while leaving us almost nothing to hold on to. By the time telescopes turned toward it, it was already slipping away. This was the echo Atlas carried when it arrived 3 years later. It, too, traced a hyperbolic path, an exile moving too swiftly to remain. It, too, refused to behave as expected. Where ʻOumuamua had been too stable, Atlas was too fragile. Where ʻOumuamua lacked a coma, Atlas displayed one, but then disintegrated in spectacular collapse. They were mirror images of unpredictability. One a stone that held together too well, the other a comet that fell apart too soon. To the scientific community, this echo was unsettling. If both of the first two major interstellar objects observed had been strange, then perhaps strangeness is the rule, not the exception. Perhaps our expectations, shaped by solar system comets and asteroids, are hopelessly provincial. Interstellar space may be filled with bodies that carry chemistries and structures beyond what our local environment can produce. The poetry of it cannot be ignored. ʻOumuamua as the messenger, Atlas as the ghost, two voices from other suns, singing in dissonance with everything we thought we knew. The echo between them is not only scientific but philosophical. They remind us of the limits of our categories, the fragility of our knowledge. They teach us that the universe is not obliged to give us neat answers. And yet, there is continuity in their mystery. Both objects left behind data that refuses to sit comfortably in textbooks. Both inspire mission proposals, craft that could one day chase future interstellar visitors, intercept them, study them before they vanish. NASA and ESA alike have begun to dream of interceptor missions that wait dormant until a new emissary appears, ready to be launched in pursuit. Without ʻOumuamua, such dreams might never have been conceived. Without Atlas, we might never have realized how urgently we need them. The echoes are also cultural. Both objects captured the public imagination. Newspapers, documentaries, podcasts spoke of alien stones, messengers from beyond, the possibility of artifacts from other civilizations. ʻOumuamua was the spark. Atlas fanned the flame. The universe, it seemed, was knocking on our door twice in quick succession. And so Atlas is remembered not only for its own fragility but as a second verse in a new cosmic song. The first verse was ʻOumuamua, silent, solid, enigmatic. The second was Atlas, bright, unstable, fleeting. Together they form a duet of mystery, a haunting harmony that still resonates in our imagination. The echoes of ʻOumuamua live on in Atlas, and they raise a deeper question still. If two of the first emissaries we have ever seen were this strange, what wonders or terrors might lie in the countless others still unseen? Science thrives on pattern. It draws strength from repetition, from the comfort of rules that apply across time and place. Apples fall, planets orbit, comets flare and fade, their motions written in the language of Newton and Einstein. Yet every so often, an anomaly drifts across the sky, and those rules seem to fracture. In those moments, scientists are forced into an uneasy place, to question not only their data, but their assumptions. 3. Atlas was such a moment. Its brightness rose too quickly, then collapsed. Its body fractured into dust before it could be studied in depth. Its trajectory marked it as interstellar, and yet its behavior was unlike any comet familiar to us. It appeared fragile, alien, inscrutable, and science, with all its instruments and equations, was left unsettled. The first reaction was caution. In astronomy, extraordinary claims demand extraordinary evidence. Researchers remembered the firestorm of speculation that followed ʻOumuamua, the debates over whether it was a shard of hydrogen ice, a nitrogen iceberg, or even an artificial probe. Many were determined not to repeat the same cycle of sensationalism. Atlas, they insisted, was a comet. It bore a coma. It shed gas and dust. It broke apart under the sun's heat. Nothing more was required. But beneath that caution lay unease. For if Atlas was a comet, it was a comet unlike any we had seen. Its rapid brightening was inconsistent with familiar models. Its fragmentation was extreme, and its interstellar origin meant that whatever chemistry lay within it was forged under conditions beyond our solar system. A comet, perhaps, but a comet that spoke in an unfamiliar dialect. Within research papers, language grew tentative. Phrases like unusual, peculiar, uncertain appeared. Scientists described the object's fading coma in clinical detail, but the tone betrayed humility. They knew they were confronting something they could not easily explain. The data was too sparse, the object too fleeting. Once again, as with ʻOumuamua, humanity had been offered a riddle and given no time to solve it. For some, this was frustrating. For others, it was exhilarating. Science advances not only through answers but through the stubborn presence of questions. Anomalies, after all, are the seeds of revolution. It was an anomaly that led Einstein to relativity. It was an anomaly that led to quantum mechanics. And now, perhaps, these interstellar visitors were anomalies of a new kind, messengers, reminding us that our solar system is not the measure of all things. Speculation arose, as it always does. Some wondered if Atlas was a fragment of a larger interstellar body, torn apart before it reached us. Others suggested its ices were laced with exotic compounds, molecules that vaporized more explosively than those in our local comets. A few, echoing whispers from the ʻOumuamua debates, asked whether such objects might be artificial after all, probes, derelicts, or relics from distant civilizations. Most dismissed this as fanciful, but even dismissal could not erase the unease. Beyond the technical papers, in lecture halls and late-night conversations, a deeper question flickered. How should humanity respond to strangeness? Do we retreat into caution, insisting that anomalies must always yield to familiar explanations? Or do we allow ourselves to linger in wonder, to accept that some things may remain mysterious? This tension between skepticism and imagination is the heartbeat of science, and Atlas forced it into the open once again. The public, too, played a role. Newspapers and websites spoke of ghost comets and interstellar messengers. For lay people, the unfamiliar is often a source of enchantment rather than discomfort. To them, Atlas was not a failure of classification, but a reminder that the cosmos still holds secrets beyond prediction. This divergence between cautious science and imaginative wonder mirrored humanity's larger struggle with the unknown. And perhaps, in this tension, lies the true gift of Atlas. It did not give us answers, but it reminded us of the value of the questions themselves. It reminded us that humility is as much a part of science as certainty, that the unfamiliar is not an embarrassment but an invitation, that the cosmos, vast and unyielding, still has the power to defy our categories. In the end, when science meets the unfamiliar, it must learn to listen. Atlas spoke briefly, in a language we barely understood. It left us puzzled, frustrated, awed. It broke apart before we could know it fully, but in its brief life, it reminded us that the universe is not ours to domesticate. It is wild, immense, and still capable of surprising us. And as Atlas faded into memory, one question grew louder. What if it had not slipped away? What if the unfamiliar had remained within reach? There is a delicate balance in the cosmos, a razor-thin line between freedom and captivity. Every stone, every comet, every grain of dust that drifts near a star must face this choice. Will it remain bound, caught in orbit, or will it escape, cast back into the endless dark? For Atlas, the balance tipped toward freedom. Its velocity carried it beyond the sun's reach, its path bent but not broken by gravity's embrace. It came and it left, as swiftly as a passing thought. But what if the story had been different? What if the sun's gravity, immense and patient, had triumphed? What if Atlas had not slipped away but had been captured, drawn into orbit, bound forever to our solar system's great clockwork? The thought experiment is tantalizing, not only for its scientific implications but for its philosophical weight. To imagine Atlas staying is to imagine an alien relic woven permanently into our skies, a reminder of other suns circling with us in our daily heavens. To understand what capture would mean, we must first understand how close we came. The difference between escape and imprisonment lies in speed, in the mathematics of orbital mechanics. Atlas entered with a hyperbolic trajectory, its velocity too great for the sun to hold. Yet had it been moving just slightly slower by a margin of only kilometers per second, the story might have changed. A brush with Jupiter, Saturn, or even Earth could have drained enough momentum to trap it. Gravitational interactions, subtle as whispers, might have bent its path into an ellipse. Instead of fleeing, it would have circled. Instead of farewell, we would have had permanence. Imagine it. A new body added to the solar system's family. Perhaps an eccentric comet, its orbit stretching out into the distant Kuiper belt before plunging back toward the Sunday. Perhaps a satellite of Jupiter, captured by that giant's immense gravity and set to circle among its chaotic moons. Or perhaps something stranger still, a fragment parked in an odd, unstable orbit, neither asteroid nor comet, a foreigner that would never quite belong. The scientific consequences would have been staggering. For the first time, we would not merely glimpse an interstellar traveler, we would have one within reach, to study at leisure. Every telescope on Earth would have turned toward it. Space agencies would have debated missions, perhaps even launched probes, eager to touch its surface, to taste its dust. We would not need to wonder about its chemistry, its isotopes, its history. We could know. More than that, the permanence of Atlas would have shifted our sense of the solar system itself. The planets and moons we know are family, born under the same star, forged from the same cloud of dust. Atlas would have been a stranger in that family, a reminder that the solar system is not sealed. It would have been proof, written in the sky, that our star shares its neighborhood with the galaxy, that the boundaries we imagine are illusions. And then, of course, there is the poetry. Imagine children learning the planets, the moons, and then, spoken with the same reverence. And Atlas, the interstellar one. Imagine nights where it blazed across the sky on its long orbit, a pale reminder that we are not alone. It would have been a relic of another sun, visible to all, a cosmic souvenir preserved within reach. But beyond science and poetry lies something more haunting, the recognition of fate. Atlas's actual story was one of loss, disintegration, escape, vanishing. The counterfactual is one of permanence capture, survival, presence. To imagine gravity winning is to confront how precarious our glimpses of the universe are, how much depends on fragile margins of velocity and trajectory. It is to realize that the difference between knowing and never knowing can be measured in meters per second. There is, too, an echo of human longing in this imagining. We are a species hungry for permanence, for possession. When something extraordinary brushes past us, we ache for it to stay. But the cosmos does not yield to that hunger. It offers us beauty, then takes it away. The fantasy of Atlas captured is, in truth, a reflection of our own desire to hold what cannot be held, to anchor what is destined to drift. And yet, thought experiments matter. They stretch the mind, they remind us of what is possible, they inspire us to prepare for the next opportunity. If Atlas had been captured, humanity would have built missions, sent explorers, transformed science. It did not, and yet the imagining drives us forward still. The next interstellar object may linger just a little longer. The next one may give us the chance we dream of. In the quiet mathematics of celestial mechanics, Atlas slipped away. But in imagination, gravity can win. And in that imagined victory, we glimpse a universe not of fleeting visitors, but of permanent connections, where the stars share their relics and we are wise enough to keep them. The sun is not only the heart of our solar system, it is its jailer. Its gravity binds planets, comets, and asteroids alike, dictating their paths with an authority that is both gentle and absolute. From the vast arcs of Neptune to the swift circuits of Mercury, all bodies dance to the rhythm of its pull. To be born under the sun is to be bound to it forever, unless some great violence tears you away. But 3I, Atlas was not born here. It slipped in from the interstellar dark, carrying momentum that belonged to another star. The sun bent its path, but could not claim it. Atlas came too fast, a traveler who paused briefly at the edge of the fire before hurrying onward. And yet, what if things had been different? Imagine the sun capturing Atlas, seizing it as part of its family. This would not be an act of force, but of subtlety, an almost invisible adjustment of trajectory. To capture an interstellar body requires exquisite timing, a delicate alignment of speed, angle, and gravity. In the realm of celestial mechanics, capture is rare, but not impossible. A slight nudge from Jupiter, a close brush with Saturn, even a faint interaction with Earth could have bled away just enough energy to transform a hyperbola into an ellipse. In that alternate history, Atlas would not have fled. Instead, its path would have curved inward, looping back around, drawn into the embrace of our star. A comet from another sun, forever bound to circle ours. The scientific implications of such capture are staggering. An interstellar object trapped in orbit around the sun would become a permanent laboratory. Unlike ʻOumuamua, which vanished before our instruments could truly see it, unlike Atlas, as we knew it crumbling to dust before our questions were answered, this alternate Atlas would remain. Each perihelion, each close pass to the sun, we could study it again. Each return would bring new opportunities, new instruments, new missions. One can imagine the global response. The astronomical community would name it not only with a designation but with reverence. Space agencies would draft mission proposals immediately. Robotic explorers like Rosetta for Comet 67P or OSIRIS-REx for asteroid Bennu would be planned with urgency. But this time, the stakes would be greater, for Atlas would not be local, it would be alien in the truest sense. Its dust and ice would hold signatures of another system's chemistry, untainted by our sun's nursery. Think of what such a body could tell us. The isotopes of hydrogen and oxygen in its ices would carry the fingerprint of its parent star's nebula. The ratios of carbon and nitrogen would whisper of conditions in some distant disk of creation. Even the dust grains might bear scars of supernovae or cosmic rays endured across eons of interstellar drift. To study Atlas, captured by the sun, would be to hold in our hands the chemistry of another world, another sky. And the symbolism would be no less profound. In our skies would move a permanent reminder that the universe is not closed, that the solar system is not an isolated kingdom. Children looking up could be told, among the planets and moons and comets, there is one that does not belong, one that was born under another sun, but now circles ours. A cosmic immigrant, a naturalized member of our family of worlds. Yet capture is not only science and symbolism, it is danger, too, for a captured Atlas might not circle harmlessly. Its orbit could be eccentric, plunging near the sun and swinging outward again, crossing paths with the inner planets. It could threaten collisions, destabilize resonances, send fragments into dangerous paths. To invite a stranger into the family is to risk disruption. The solar system is a delicate clock, and one misplaced gear can alter the rhythm of the whole. Still, for all its risks, the vision is intoxicating. Atlas, no longer a ghost, no longer a fleeting visitor, but a permanent companion to our Sunday. Its orbit would mark the sky like a scar, a visible reminder of the galaxy's wider life. Astronomers would trace its path with reverence. Poets would speak of it as a bridge between stars. Humanity would never again be able to pretend that our skies are only our own. In reality, of course, the sun did not capture Atlas. Its velocity was too great, its angle too sharp. The laws of physics, cold and impartial, allowed no such fate. It came, it flared, it disintegrated, and it was gone. But in imagination, we can allow gravity to win. And in that imagined victory, we glimpse what the future may yet hold for one day. Another interstellar traveler may cross our path at just the right speed, just the right angle, and the sun may keep it. And when that day comes, the universe will have changed. For the first time, a fragment of another star will not pass us by, but remain. And the boundary between ours and theirs will dissolve as the solar system becomes a little less closed, a little more a part of the galaxy's endless exchange. If the Sun is the great ruler of the solar system, then Jupiter is its gatekeeper. With mass more than twice that of all the other planets combined, its gravity reaches far beyond its swirling clouds, shaping the paths of comets, shepherding asteroids, and casting countless wanderers into exile. Jupiter is the warden at the boundary, the one that decides who stays and who goes. When 3I, Atlas, entered the solar system, it passed not far from this giant. Had its trajectory shifted only slightly, Jupiter's immense pull might have claimed it. Instead of continuing on its hyperbolic escape, Atlas might have been bent into orbit an alien moon circling the most massive planet in our system. Such captures are not unheard of. Jupiter already keeps irregular satellites small, misshapen moons with chaotic paths, believed to be captured asteroids or comets. They move in eccentric orbits, some even retrograde, circling against the planet's rotation. They are evidence that Jupiter with its vast gravitational reach, is capable of stealing bodies from the solar system's periphery. If Jupiter can capture local wanderers, why not one from beyond the stars? Imagine it, Atlas, no longer a transient visitor, but a permanent moon of Jupiter. A faint, icy companion drifting among the giant's retinue, circling with the Galilean moons, the Trojan asteroids, and the storm-laden clouds of the gas giant itself. A moon unlike any other, not because of its shape or size, but because of its origin. An alien emissary, captured and preserved, orbiting the largest planet of our system. For astronomers, such a capture would have been extraordinary. It would have given us an object, not merely nearby, but close enough to study in exquisite detail. Jupiter, though distant, is within reach of spacecraft. Missions like Galileo and Juno have shown us its clouds and magnetic fields. Europa, Callisto, and Ganymede have been studied with a precision unimaginable a century ago. A captured Atlas among them would have been irresistible. A mission would already be on the drawing board. Probes designed to orbit or land upon this interstellar moon, to sample its surface, to drill into its ice, to bring back fragments. Imagine the triumph. Laboratories on Earth analyzing material from another star, not gathered by chance dust, not inferred by distant light, but brought home in human hands. The periodic table itself might have gained new entries, new isotopes, new combinations of elements forged in stars far from our own. And beyond the science, there is the symbolism, a moon that does not belong, a fragment of another system circling a planet of ours. School children learning not only of Io's volcanoes, Europa's oceans, Ganymede's magnetism, but also of Atlas, the alien one, a moon from another sun, captured by Jupiter, forever circling in the twilight of our solar system. It would have changed the way we speak of the heavens. But capture by a planet is not only poetry, it is peril. A body in irregular orbit can destabilize, fragment, collide. Jupiter's moons are not quiet companions. They are locked in resonances, pushing and pulling, shaping tides and orbits. An alien moon might not survive long in such a family. It could break apart under tidal stress, its fragments scattering into rings or falling into Jupiter itself. Perhaps that fate would be no less wondrous. A rain of alien dust into Jupiter's storms, a visible reminder that even giants consume what they capture. Yet even in destruction, knowledge could be won. If Atlas shattered around Jupiter, its dust could be studied from afar, drifting like faint auroras across the giant's sky. Its chemistry would still be written in light, detectable by spectrometers across the world. In science, even loss is data. There is another possibility still. Perhaps Atlas might not have circled Jupiter, but Saturn. Its gravity, though weaker than Jupiter's, is still vast, and its rings already hold the wreckage of captured bodies. A fragment from another star, embedded among those rings, would have been a discovery beyond imagination, an alien relic framed in Saturn's luminous crown. The most beautiful planet in our system, adorned with the most foreign of ornaments. The possibilities multiply. Neptune, too, has captured moons Triton most famously, once a wandering body of the Kuiper belt, now circling as a captive. If Neptune could keep a local wanderer, could it not have kept an interstellar one, a frozen alien moon circling a blue giant at the edge of the solar system, shrouded in silence, waiting for humanity to arrive? And in all these imaginings lies a deeper truth. Capture is not just mechanics, it is symbolism. It is the idea that the solar system is not closed, that our family of worlds is open to adoption, that our planets, so long considered isolated, may one day harbor companions from the stars. In reality, Atlas escaped. It brushed past Jupiter's reach, refusing capture, refusing to join. But in imagining it as a moon, we glimpse a future that may yet come. For interstellar objects will keep arriving. One day, One of them may linger just long enough, move just slowly enough to be taken. And then, for the first time, our solar system will not be purely ours. It will carry within it a child of another sun. And when that day comes, the story of Atlas will be remembered not as a loss, but as a foreshadowing the ghost of what might have been and the promise of what will one day be. If Atlas had stayed, if the Sun or Jupiter had claimed it, what would we truly have held? Would it have been nothing more than a frozen lump of debris, an unremarkable stone adrift in a foreign sky? Or would it have been something far greater, a living archive, a vessel carrying secrets from a star we will never see? The difference between debris and archive lies not in mass or brightness, but in meaning. Debris is accidental, a byproduct of violence, a fragment stripped from its source and left without purpose. An archive, by contrast, is memory preserved, knowledge carried forward, a record waiting to be read. The haunting truth of interstellar bodies like Atlas is that they are both at once accidents of celestial mechanics and yet archives of unimaginable value. Every comet is a time capsule. Within its ices lie the frozen chemistry of the early days of its system's birth. Our local comets preserve the story of the Sun's nursery, the ratios of hydrogen isotopes in their water, the fingerprints of carbon compounds, the dust of ancient collisions. By studying them, we glimpse the conditions from which Earth itself arose. But a comet from another star, such as Atlas, would be more than a time capsule. It would be a foreign library, its chemistry written in the dialect of another sun. Consider what that means. Our sun formed in a cluster, likely alongside hundreds of other stars. Each star carried its own protoplanetary disk, each disk with its own temperature, gradients, pressures, and elemental balances. Some produced rocky planets, others icy giants, others barren belts of debris. A comet ejected from such a disk would bear the signature of that system's unique history. Its isotopes would not match ours. Its carbon chains might be longer or shorter, its organics richer or poorer, its water might carry ratios that tell of a different path to planetary oceans. To hold Atlas would be to compare worlds not in theory, but in substance. Imagine the instruments that might have been turned upon it. Mass spectrometers analyzing the gases it released as it warmed in sunlight, X-ray diffractometers probing the structure of its minerals, even small landers drilling into its crust, pulling out cores of ice that had never before been touched by starlight since leaving its birth system. Each measurement would answer questions that we do not even yet know how to ask. Each sample would challenge the assumption that our solar system is a template for all others. And yet, even without instruments, the symbolism alone would matter. A fragment from another star, circling ours, what more profound reminder could we have of our connection to the galaxy? For millennia, humans looked up at the night sky and saw only separation, stars as distant, unreachable lights. But a captured Atlas would embody the opposite truth. It would show that matter does not remain confined to its birthplace, that stars shed their fragments like seeds, that the galaxy is a shared garden where systems exchange their dust. Would such an object be lifeless? Perhaps, most likely. And yet, even lifeless archives speak. They speak of the chemistry of creation, of the violence of ejection, of the endurance of matter across eons. They carry whispers of the processes that forged them, whispers that, if heard, expand our own story of existence. But there is another, more daring possibility. Could Atlas have carried within it the seeds of life itself? Not in the form of organisms, fragile and unlikely to survive the cold drift between stars, but in precursors, amino acids, complex organics, the scaffolding upon which biology might one day rise. In our own comets, such molecules have been found. Why not in those of other suns? If life is to be a galactic phenomenon, spread not just through planets, but through the silent scattering of comets, then Atlas might have been an ark, not of creatures, but of chemistry waiting to awaken. This possibility raises the stakes of its absence, for in losing Atlas, we may have lost not just a stone but a chapter of the galaxy's living history. We may have lost a record that could have told us whether life is written in universal language or in dialects specific to each star. Still, imagination allows us to hold what reality denied. If Atlas had stayed, if we had captured it, we would now be debating missions to unlock its archive. Teams of scientists would be mapping its surface, charting its fractures, cataloguing its jets of vapor. Philosophers would be writing of its meaning, an alien stone circling among our planets, proof that we are not isolated. Poets would speak of it as a library in ice, a chronicle of another world delivered to our door. Debris or archive, accident or artifact, perhaps both, for in the cosmos, accidents often carry the greatest meaning. A star explodes, and in its debris are the heavy elements that build life. A planet collides, and in its fragments, new moons are born. Atlas was an accident, yes, but had it stayed, it would have been an accident turned into archive, debris transformed into memory. And so the question lingers. When interstellar visitors pass us by, are we watching only stones, or are we watching libraries burn in the sky, archives lost to the void? We cannot know, not yet. But the thought is enough to keep us watching, waiting, longing for the day when one will not slip away. Every comet is a vessel of memory. Its frozen shell, locked in darkness for billions of years, preserves the raw chemistry of its birthplace. When sunlight touches it, the comet exhales that memory into space, water vapor, carbon monoxide, methane, ammonia, complex organics, all released in a fleeting whisper. By catching that whisper with spectrometers, astronomers read the story of the comet's origin, a story written long before planets formed, long before life arose. Our solar system's comets have told us much about ourselves. From Halley to 67P, Churyumov-Gerasimenko, we have learned that their ices carry amino acids, sugars, and building blocks of life. We have traced isotopes of hydrogen in their water, comparing them to Earth's oceans, asking whether our seas were filled not only by volcanic steam, but by icy messengers from the outer reaches. Each comet is a page from our own prologue. But 3I, Atlas was not one of ours. Its chemistry was not the story of the sun's nursery, it was the story of another. Imagine what we might have found if Atlas had been captured, preserved as a permanent companion to our skies. Its ices would bear the fingerprint of a different star's nebula. Perhaps its deuterium to hydrogen ratio would be unlike anything seen here, telling us of cooler or warmer conditions in its birth cloud. Its carbon isotopes might reveal processes foreign to our solar system. Even the balance of noble gases, argon, krypton, xenon, could speak of pressures and temperatures we cannot replicate in theory alone. The diversity of planetary systems is already evident from exoplanets. Some stars harbor hot Jupiters, gas giants circling in days. Others host super-Earths, worlds larger than ours yet rocky, orbiting in strange resonances. If planets are so diverse, then surely their comets must be as well. Each carries a unique mixture of elements, sculpted by its star's light, its gas disk, its collisions. By studying Atlas, we would hold in our hands the physical chemistry of another system, not inferred from light years away, but directly sampled within our reach. Consider, too, the organics. Our comets are rich in carbon chains, molecules that hint at prebiotic chemistry. If Atlas carried such organics, would they resemble ours, or would they be different, shaped by an alien balance of elements? Perhaps its ices carried long, complex molecules never before seen, chains that in some other world might seed biology. Or perhaps its chemistry would be sparse, sterile, a reminder that not every system carries the seeds of life. Either discovery would transform our understanding of the universe. Either life's chemistry is universal or it is parochial, confined to certain stars. And then there is the possibility of anomaly. What if Atlas had carried isotopes that defied known ratios? What if its dust grains bore structures that hinted at processes unknown in local physics? Even small deviations would raise enormous questions. Did its star form in a different kind of molecular cloud? Did supernovae nearby seed it with heavy elements? Did conditions in its nursery create paths of chemistry that our models cannot yet predict? In one captured fragment, the universe might have shown us that the periodic table itself speaks in dialects. The methods to reveal these truths already exist. Telescopes can analyze cometary spectra from afar. Probes, if sent, can drill, heat, and study ices directly. A mission to Atlas would have been like sending a geologist into another solar system's museum. Every sample, every molecule, every isotope would have been a clue to the processes that shape worlds beyond our own. But beyond data lies reflection. To know the chemistry of another star's comets is to know the galaxy differently. No longer would stars be distant, silent lights. They would be connected to us by shared matter, by exchanged debris. We would know not only their light but their substance, their building blocks, their fingerprints written in ice. It is humbling to imagine what might have been, to think that a single stone could carry such weight that an object smaller than a mountain might reveal truths about stars we will never reach. That chemistry, so often thought of as the study of the small, becomes here the study of the infinite. And yet, the truth slipped away. Atlas disintegrated. Its chemistry was lost to dust, scattered beyond recovery. What might have been a library became ashes in the void. We are left only with imagination, with models, with the longing for what we could have known. Still, the idea endures. Atlas showed us that such knowledge is possible, that the chemistry of other suns can, at times, drift close enough to touch, and that one day, when another interstellar traveler appears, and one surely will, we must be ready. We must have the instruments, the missions, the resolve to catch the chemistry of other suns before it vanishes again into the dark. Until then, Atlas remains a symbol, a fragment of another star that came too close to hold, a reminder that the universe is not silent but speaks in molecules and isotopes, in dust and ice. That to study such a fragment is to listen to the voices of other suns, carried across the galaxy in the fragile breath of a comet. If Atlas had stayed, science would not have remained passive. Humanity, restless and curious, would have turned the full weight of its laboratories toward this alien guest. For here, at last, was the chance to hold in our hands not just a fragment of our solar system, but a fragment of another star. The first tools would have been telescopes. Even before probes could be designed or launched, astronomers would have trained every eye in the sky upon it. The Hubble Space Telescope, still orbiting above Earth, would have caught its faint light, splitting it into spectra, measuring the telltale lines of water, carbon monoxide, methane, and organic molecules. Ground-based observatories, equipped with powerful spectrographs, would have compared its chemistry to that of local comets, searching for differences that might reveal its origin. The James Webb Space Telescope, with its infrared vision, could have peered into its ices, detecting compounds too faint for any other instrument. But telescopes are only the beginning. Astronomy is a science of distance, but comets invite touch. They release dust, scatter particles, exhale their inner chemistry into space. A captured atlas would have drawn us closer. Proposals for missions would have sprung up within months. Orbiters, landers, sample, return, spacecraft. NASA, ESA, JAXA all would have seen in Atlas an irresistible target. The precedent already exists. In 2014, ESA's Rosetta mission landed on comet 67P, Churyumov-Gerasimenko, revealing a world of cliffs and pits, jets of vapor, organics hidden in ice. In 2020, NASA's OSIRIS-REx gathered samples from asteroid Bennu, bringing them back to Earth in 2023. JAXA's Hayabusa missions returned grains from asteroids Itokawa and Ryugu. Each of these triumphs was a rehearsal, preparing humanity for something greater. A permanent atlas in orbit around the Sun or Jupiter would have been that something greater. Imagine the mission profile. A spacecraft launched with ion propulsion, slowly spiraling outward to intercept the alien comet. Instruments on board designed not only to map its surface, but to analyze its chemistry in situ. A harpoon or drill to collect samples, sealed in capsules to return to Earth. Laboratories waiting, white-coated scientists preparing to open the box of an alien library. The day such a sample returned would be marked as one of humanity's great scientific milestones, the first time we touched material forged under another sun. The possibilities are breathtaking. A single core drilled into Atlas might have revealed isotopic ratios unknown in our solar system. A dust grain might have carried evidence of ancient supernovae, embedded like scars of violence long past. An ice sample might have contained amino acids, sugars, or organics that mirrored or defied our own. Every fragment would have been a revelation, every molecule a message. And not only Earth-bound laboratories would have played a role. Space itself could have been a laboratory. An orbiter could have hovered near Atlas for years, measuring the gases released as sunlight warmed it, watching how its surface evolved, how fractures spread, how dust was shed into space. Instruments could have mapped its magnetic interactions, its thermal properties, its density and structure. In time, it might even have hosted landers, small machines designed to crawl across its alien surface, tasting, drilling, measuring. The value of such a laboratory cannot be overstated. With exoplanets, we learn from light alone tiny dips in starlight, faint shifts in spectra. With comets like Atlas, we could learn from matter itself, no longer inferring at a distance, but touching, tasting, knowing. It would have been as though another star had mailed us a package, and for once, we had opened it. But beyond instruments and laboratories lies something more profound: imagination. The sight of an interstellar object, captured and studied, would have reshaped how we think of ourselves. No longer would the solar system seem a sealed family. It would be porous, open, connected to the galaxy. We would look up at the night sky knowing that fragments of those distant stars sometimes stay, sometimes circle, sometimes wait for us to reach them. There is, too, a philosophical irony. In reality, humanity dreams of sending spacecraft to other stars, a journey of centuries, perhaps millennia. But in Atlas, the stars had sent a fragment to us. A mission to a captured Atlas would not have been us reaching outward, but us reaching inward, grasping what the galaxy had already placed in our path. It would have been a humbling reminder. Sometimes we need only open our hands to catch the gifts drifting by. Of course, reality denied us that chance. Atlas broke apart, its dust scattered, its core dissolved, its archive destroyed. We are left with no laboratory, no sample, only faint measurements of light before it disintegrated. But the thought remains a blueprint for the future. When the next interstellar object comes, perhaps slower, perhaps sturdier, we will be ready. We will have laboratories not only on Earth, but in orbit, in space, prepared to turn the galaxy's debris into archives of knowledge. Until then, Atlas lingers in imagination, a ghost comet that might have been a laboratory, a living archive that slipped away. And in its absence, we build laboratories of another kind, observatories, spacecraft, instruments waiting for the next emissary. For the universe will not stop sending them. One day, another atlas will arrive, and next time perhaps, we will be ready to keep it. Every fragment of stone drifting through space is more than a rock. It is a witness to the birth of stars, to the collisions of worlds, to the explosions that seeded the galaxy with heavy elements. In its silence, it carries a testimony written not in words, but in atoms, isotopes, and scars. 3I, Atlas, had it remained, would have been such a witness, a relic not of our sun's story, but of another's. To understand its value, one must see comets not as isolated bodies, but as archives of cosmic history. Each grain of dust inside Atlas would have been a page written in the language of astrophysics. Some grains may have condensed in the cool outskirts of a foreign star's protoplanetary disk, frozen in place before planets even formed. Others may have been forged in ancient supernovae, heavy elements flung into interstellar clouds, later trapped in the ices of a newborn system. A fragment of magnesium here, a trace of xenon there, tiny but profound, each element a clue to past events scattered across the galaxy. Our own comets have shown us glimpses of this. Analysis of dust from Comet Wild 2, captured by NASA's Stardust mission, revealed grains older than the solar system itself. Interstellar dust, born in distant supernovae, preserved in a comet orbiting our Sunday. Already, within our local bodies, we see traces of the wider galaxy. What, then, might an interstellar comet like Atlas have carried? Not just traces, but the primary record itself, an unbroken chain of memory from a star, not our own. Imagine opening that record. Within Atlas's ice, we might find isotopic ratios that speak of a cooler nebula, one where carbon chemistry flourished differently. We might uncover grains coated in compounds never stable in our solar system, evidence of conditions beyond our models. Some particles might even predate the star that birthed Atlas' true interstellar nomads, older than any planet, older even than the Sun itself. In Atlas, we might have found pieces of stars that lived and died long before Earth was born. Such a discovery would not merely expand knowledge, it would deepen our sense of time. Humanity thinks in centuries, sometimes in millennia, but comets think in billions of years. They are slow archivists, carrying their records silently across the void. Atlas, had it remained, would have been a chronicle of galactic time, not of human events, but of cosmic epochs. To touch it would have been to reach into the past, not of our world, but of others. The emotional weight of such a relic cannot be overstated. To study Atlas would be to confront the reality that the galaxy is not an abstract collection of stars, but a living history of exchange. Stars form, they shed debris, their fragments drift, they seed each other with matter. The Milky Way is not static, it is a great river of exchange, carrying pieces of itself across light years. A captured Atlas would have been proof that we are participants in this river, whether we choose to be or not. There is also a haunting symmetry here. Our own solar system too has ejected its fragments. Asteroids and comets cast away by Jupiter's gravity, drifting endlessly into interstellar space. Even now, Voyager 1 and 2, though not natural, carry pieces of Earth into the stars. Somewhere, billions of years from now, fragments of our system may brush against another, becoming their Atlas, their alien archive. To hold Atlas here would have been to glimpse what we, too, give to the galaxy. But we did not hold it. It broke apart, its fragments dissolving in sunlight, its memory erased before it could be read. And so we are left only with shadows, the shadows of what it might have told us, the faint outlines of a cosmic history we almost held but lost. Yet even loss can illuminate. The very fact that Atlas existed proves that stars share their memories through debris. The mere act of seeing it reminds us that we live in a galaxy, alive with movement, with exchange, with stories flowing unseen through space. And perhaps, in this, Atlas fulfilled its role. It did not give us its full record, but it reminded us that such records exist. It left us hungering, searching, ready to recognize the next. In the end, Atlas was not simply a comet, it was a shadow of cosmic history, passing briefly through our sky. And though it is gone, the idea it carried remains, that in every drifting stone, in every fragment of ice, the galaxy has written its chronicles. All we must do is learn to read them. The human mind is restless in the face of mystery. When an object defies expectation, when data refuses to fit neatly into the categories of science, imagination rushes in to fill the gap. So it was with ʻOumuamua, and so it became, briefly, with Atlas. The question whispered at the edges of the debate was not only what is it made of, but who, if anyone, made it. Most scientists resisted the leap. The default explanation was natural: a comet, an icy fragment ejected from its parent star system, drifting for millions of years until chance carried it across ours. Nature, after all, is stranger than fiction often allows. But ʻOumuamua had unsettled the field by refusing to behave as expected. Its odd acceleration, its unusual shape, its lack of visible outgassing all raised the spectre of something more deliberate. Harvard astronomer Avi Loeb suggested, to much controversy, that it might be an artificial object, perhaps a derelict probe, perhaps a sail driven by starlight. Most disagreed, yet the seed was planted. The galaxy might not only send us stones, but also artifacts. When Atlas appeared, that speculation resurfaced. Here was another interstellar visitor, and again it defied our expectations. Instead of being too stable, as ʻOumuamua was, it was too fragile. It brightened too quickly, then collapsed into dust. Was this merely the behavior of an unstable comet? Or could it have been the disintegration of something less natural, an alien structure, weakened by eons, crumbling under the heat of a new sun? Science, cautious and grounded, leaned firmly toward the cometary explanation, and rightly so. Extraordinary claims demand extraordinary evidence, and Atlas gave no proof of artificial origin. But in the silence of its disintegration, imagination flourished. The public, unburdened by academic caution, whispered of derelict craft, of probes long dead, of alien hands that may once have shaped it. The question of alien hands is less about probability than about possibility. The odds that any given interstellar object is artificial are vanishingly small, but the odds that civilizations, if they exist, would send fragments, probes, or machines into the void are far greater. Over millions of years, the galaxy might be littered with the remains of technologies as fragile and as aimless as comets. To deny the possibility is to close the door on wonder. To accept it is to acknowledge that we cannot yet know. What would it mean if Atlas had been artificial? The thought is staggering. A captured Atlas, intact and studied, could have revealed engineering beyond our comprehension, alloys unknown to Earth, structures designed for endurance across light years, patterns hinting at communication or intent. Even in ruins, even in dust, it could have carried evidence of minds beyond our own. To hold such a relic would not be science alone, it would be philosophy, history, theology, all rewritten in an instant. But perhaps the truth is more subtle. Perhaps the question of alien hands is not literal, but metaphorical. Even if Atlas was natural, its arrival still confronts us with alien realities, the chemistries of other suns, the dynamics of other systems, the stories of worlds unseen. In studying it, we would still be touching the hands of the alien, not in crafted machines, but in the artistry of cosmic physics. Nature itself, across the stars, is the alien mind we seek to know. Still, the allure of the artificial persists. We are a species attuned to pattern, to purpose. We struggle to accept randomness at cosmic scale. When a fragment from another star arrives, we cannot help but wonder whether it carries intent. It is the same instinct that made early humans look at lightning and see gods, that made ancient cultures look at comets and see omens. Atlas became, however briefly, another canvas for that timeless projection, the hope and the fear that we are not alone. In reality, Atlas offered no evidence of alien hands. Its breakup, its brightness, its fragility all fit within the bounds of natural explanation, even if at the edges of our models. But the speculation it inspired is itself a lesson, for it shows how the unfamiliar unsettles us, how we crave meaning in the face of the unknown, and it reminds us that one day the speculation may not be misplaced. One day, among the countless interstellar stones, there may be one shaped not by chance, but by choice. If Atlas had stayed, and if it had proven to be natural, its value would have been immense. But if it had shown even the faintest sign of design, it would have been immeasurable. It would have changed everything: our science, our philosophy, our place in the universe. And so, the question of alien hands lingers. It lingers not because Atlas was artificial, but because Atlas reminded us that such questions are worth asking. Every fragment from beyond our sun carries with it not only chemistry but possibility. And possibility, in the end, is the most powerful archive of all. In the spring of 2020, astronomers watched with growing dismay as 3I Atlas began to fall apart. What had once promised to be a bright comet, perhaps even visible to the naked eye, became instead a ghost, unraveling into fragments too faint for meaningful study. By May, its nucleus was gone, its promise dissolved into dust. Atlas, the interstellar messenger, had destroyed itself before it could speak. But what if it had not? Imagine a different history. Imagine Atlas, instead of crumbling, had remained whole. A nucleus intact, a structure resilient against the sun's warmth, a body strong enough to survive perihelion, to swing past our star and continue on its path, or, in the counterfactual we follow, to remain captured in orbit. The breakup that never happened is more than an exercise in fantasy. It is the exploration of what knowledge, what meaning, was lost in those fractured weeks of 2020. A comet that holds together is a comet that tells stories. Rosetta's visit to Comet 67P showed us this truth. Cliffs and plains, pits and fractures, all bearing witness to billions of years of survival. Each crack records stresses endured, each jet of vapor maps chemistry to history. Had Atlas remained intact, we could have mapped its surface, read its scars, traced its biography across eons of interstellar drift. Instead, its biography was torn into illegible scraps, scattered in the solar wind. The fragility of comets is part of their allure. They are not built to last. They are fragile archives, vulnerable to the very heat that makes them visible. But Atlas was more fragile than most. Its rapid brightening, followed by sudden collapse, betrayed a weakness deep within. Perhaps it was already cracked before it entered our system, fractured by tidal forces in some distant past. Perhaps cosmic rays had weakened it, or its ices were unusually volatile. Whatever the cause, it could not withstand its moment in the Sunday. Yet, in imagining the breakup that never happened, we glimpse what could have been. A solid Atlas might have become a long-period comet, circling back every few millennia, a recurring reminder of alien chemistry. A captured Atlas might have orbited Jupiter, stable enough to endure centuries, waiting for our probes to arrive. An intact Atlas would not only have given us time, it would have given us continuity. Instead of a brief flare, we would have had a permanent presence. The difference between fragility and endurance is not only scientific, it is symbolic. The breakup of Atlas was a metaphor for the human condition. Glimpses of greatness dissolving too soon, promises unfulfilled. The intact Atlas, by contrast, would have been a symbol of resilience, of persistence across eons. It would have been a reminder that even fragile things can endure, that even exiles can find a home. Science, too, would have been transformed. An intact nucleus would have allowed detailed study. Instruments could have measured its density, revealing whether it was a loose aggregate or a solid core. Landers could have anchored themselves, drilling into layers that recorded its history. A sample return mission could have brought back untouched fragments, frozen for billions of years. Instead, we were left only with telescopic spectra, faint and incomplete, blurred by the dust of disintegration. Even philosophy would have felt the difference. A surviving Atlas would have been a long-term companion, visible to generations, an alien relic among our familiar comets. It would have reshaped our perception of permanence. We live in a universe of passing things, of stars that burn out, of lives that end, of comets that crumble. To have one endure an alien one, no less would have been a gift of constancy in a cosmos of impermanence. But Atlas did not endure. It crumbled, and in its crumbling, it reminded us of another truth, that fragility is not failure. Fragility is revelation. Its breakup told us something real, if incomplete, that interstellar objects may be weaker, stranger, more volatile than our models predict. Its disintegration was not silence, but a half-spoken word, a fragment of a sentence, unfinished but still meaningful. Still, we cannot help but mourn the loss of what might have been. To imagine the breakup that never happened is to imagine a laboratory preserved, a library intact, a history still legible. It is to imagine a world where humanity had time enough to ask its questions, to gather its data, to hold in its hands the chemistry of another sun. Perhaps, in the end, this counterfactual is less about Atlas and more about us. We long for permanence. We long for archives that endure. But the cosmos teaches us that impermanence is the rule, not the exception. Atlas's fragility is not an error. It is the universe reminding us that knowledge is precious precisely because it is fleeting. We are not given answers easily. We are given glimpses, and we must learn to treasure them before they are gone. And so, in the story of Atlas, there are two versions, the one that happened and the one we imagine. In the first, it broke apart, leaving us dust and disappointment. In the second, it endured, leaving us archives and meaning. The truth is the first, but the hope, the dream, is the second. And in that dream, we glimpse not only what we lost, but what we must be ready to catch the next time the galaxy sends us a messenger. The solar system is a clock, and gravity is its gearwork. Every planet, every asteroid, every comet plays its part in a delicate mechanism that has turned for billions of years. Mercury races closest to the Sun, Saturn circles with its rings, Neptune glides at the edge. Even the restless comets obey, looping outward and inward, bound to return again. To understand this clockwork is to understand not only astronomy but time itself. Yet what if a foreign gear were introduced? What if Atlas, instead of fleeing, had been captured, forced to orbit within this ancient machine? The rules of celestial mechanics, steady and familiar, would have been altered, not broken, but rewritten, expanded to include a body that did not belong. In purely physical terms, the capture of Atlas would have added new mass, new gravity, new interactions. Small by planetary standards, yes, but even the smallest stone exerts a pull. If bound in a stable orbit, it might have altered resonances with other comets, nudging some onto new paths, perhaps sending others toward the inner system. Over centuries, such nudges accumulate. A captured Atlas might have subtly reshaped the architecture of comets, a butterfly effect measured not in days but in millennia. If caught by Jupiter, the changes could have been more dramatic. The giant already acts as a cosmic shield, flinging comets outward or swallowing them whole. A captured Atlas in its orbit would have become part of that ballet, a new participant in the eternal exchange between the giant and the Sunday. Perhaps it would have destabilized a Trojan asteroid or shifted the dance of Jupiter's irregular moons. The solar system is resilient, but it is not immune to change. Beyond the mechanics lies the meaning. The orbits of our system are ancient, and in them we find comfort. They are predictable, calculable, trustworthy. The ephemerides of planets are known centuries in advance. Comets return on schedule. Asteroids follow their families. But a captured interstellar object would not be part of that rhythm. It would be discordant, irregular, unfamiliar. Its orbit might not align with the ecliptic, might cut at steep angles, might move with periods beyond our experience. It would not fit into our tables of regularity. It would remind us that the universe is not always clockwork, it is improvisation as well. There is a poetry in such disruption. For centuries, humanity believed the heavens were perfect, immutable. Then came Galileo, Newton, Einstein, each revealing that the heavens obey laws, yes, but not perfection. They are dynamic, restless, alive. A captured Atlas would be another revelation. It would show us that the solar system is not a sealed mechanism, but a living system, one that can be altered by encounters with the galaxy beyond. Consider the philosophical shift. Astronomy has long defined the solar system as a family bound by origin. Planets, moons, comets, all born under the same star. But with Atlas captured, that definition would fracture. The solar system would no longer be purely native, it would be hybrid, a mixture of local and foreign. Our maps would need to mark not only what is ours, but what is borrowed, and in doing so, we would be forced to redefine home. This redefinition extends to time itself. Orbital mechanics is the language of prediction. With Newton's laws, we calculate the future positions of planets with astonishing precision. But Atlas, with its foreign momentum, might defy easy prediction. Its orbit could wobble, shift, change under the cumulative pull of the giants. It would remind us that the future is not always calculable, that even in the precision of physics there is room for surprise. Such a lesson would not be trivial, for humanity increasingly depends on the predictability of space. Satellites, missions, trajectories all rely on knowing the clockwork in advance. A captured Atlas would be a reminder that the unexpected can arrive, altering the rules. In practical terms, it would be a challenge. In philosophical terms, a gift. And beyond mechanics, there is symbolism. Atlas would have been a stone that rewrote the rules. A body that entered from outside was captured and forced us to accept that the solar system is not closed. It would embody the idea that the boundaries of systems, like the boundaries of nations, are permeable. That identity is not always a matter of origin, that what is foreign can become part of what is ours. In reality, Atlas did not alter the mechanics of the solar system. Its fragments scattered, its memory dissolved, its influence negligible. But in imagining its capture, we glimpse the fragility of our definitions. We realize that the solar system is not a static machine, but a stage where actors can enter and leave, sometimes staying to change the play. The new rules of celestial mechanics are not rules of mathematics, they are rules of humility. They remind us that no system is closed, no orbit eternal, no family without strangers. They remind us that the galaxy is not a set of isolated clocks, but a vast web of interactions where even the smallest stone can alter the rhythm of the dance. Atlas, had it remained, would have been such a stone, a new rule, a new rhythm, a new reminder that the universe is not bound by our categories. It is larger, stranger, and more open than we can imagine. For most of human history, the solar system was imagined as a closed kingdom, The sun ruled at the center, its planets circling like loyal courtiers, its comets and asteroids roaming in distant halls. Beyond Neptune lay the Oort cloud, the final frontier, a spherical fortress of icy remnants marking the edge of our domain. Beyond that silence, stars glittered in the distance, but they were separate, untouchable, their worlds forever confined to their own gravity wells. Then came ʻOumuamua, then Borisov, then Atlas, and with them the illusion shattered. The truth is humbler and stranger. The solar system is not alone. It is not sealed, not self-contained, not sovereign. It is porous, open to the constant drift of galactic debris. Interstellar space is not empty. It is alive with wanderers, comets, asteroids, fragments of planets ejected during the violent youth of stars and left to drift for millions, even billions of years. They pass each other silently, sometimes colliding, sometimes captured, sometimes simply brushing past. Our solar system is not an island, it is a crossroads. Atlas embodied this truth. Its hyperbolic trajectory was not an anomaly, but evidence of a greater current. For every interstellar visitor we detect, countless others slip by unseen, too small or too dark for our telescopes to catch. The galaxy is a river of matter, and our solar system is just one eddy in its flow. To live under the sun is to live within that current, whether we recognize it or not. This realization is both comforting and unsettling. Comforting because it affirms connection. We are not isolated in some cosmic prison. The elements that built our world are not unique to us, they are shared, exchanged, scattered across the Milky Way. Every atom of carbon in our bodies was forged in the death of ancient stars, scattered like pollen, gathered into new systems, breathed into new forms of life. Atlas was proof that this exchange still continues, that the galaxy remains a place of sharing, of mingling, of movement. But unsettling too, for if objects drift freely across systems, then no system is truly safe. A comet from another star may carry beauty, but it may also carry threat. Our solar system is open not only to visitors, but to collisions. Extinction may arrive not only from within an asteroid from our Oort cloud, but from without, a stone flung across light years, arriving without warning. Atlas was harmless, but its presence was a reminder that the door to the galaxy swings both ways. And yet, there is wonder. For in seeing Atlas, humanity was reminded of its place in the Milky Way, not as isolated observers, but as participants. The solar system breathes with the galaxy. We give and we receive. Our own comets, ejected by Jupiter's pull, are even now drifting outward, becoming someone else's Atlas in a distant future. Perhaps one day, under an alien sky, another species will look up and whisper of a strange fragment passing through a fragment from our Sunday. To hold Atlas, to imagine it captured, would have been to see this truth with permanence. A foreign stone circling our star would be a visible reminder that we are part of a larger network. It would mark the solar system not as a sealed vault, but as an open library, shelves exchanging volumes across light years. Children would grow up knowing not only of Earth and Mars, but of a moon or comet from another sun, an alien member of our family, proof that the universe is one. Philosophically, this changes everything. To believe we are alone fosters separation, insularity, fear. To know we are connected fosters humility, kinship, belonging. Atlas was not merely a comet, it was a thread in the galactic tapestry, and its passing revealed the weave of which we are part. There is also a temporal dimension. We often think of cosmic history in terms of isolated timelines, the history of the sun, the history of Earth, the history of humanity. But Atlas reminds us that histories overlap. Its atoms may have formed in the same molecular cloud as ours, billions of years ago, before drifting into another star's orbit. Its ices may have been warmed by a light we will never see. Its dust may have endured supernovae that we cannot imagine. To encounter it is to encounter a parallel history, intersecting briefly with our own before diverging again. And so, in the vision of a captured atlas, we glimpse a solar system that admits its connections. We see a family of worlds no longer purely local, but galactic in scope. We see ourselves not as citizens of one star, but as citizens of a galaxy where matter itself migrates. In reality, Atlas left us too soon, but in its brief presence, it left us this gift: the knowledge that the solar system is not alone, that stars share their fragments, that the Milky Way is not silence but dialogue, and that every comet, every asteroid, every wandering stone may be more than debris. It may be a messenger carrying the memory of another sun. Not every visitor is benign. For as long as humans have watched the sky, comets have been seen with dread. In ancient chronicles, they were portents of war, famine, the fall of kings. Their sudden appearance in the heavens unsettled societies that longed for stability. Even now, stripped of superstition, we know the fear was not misplaced. For comets and asteroids are reminders of impact, the violence that can reshape worlds in an instant. An interstellar visitor like Atlas carries with it the same shadow, but on a deeper scale. Our local comets, though dangerous, are at least predictable. They belong to the Sun, their orbits calculable, their returns forecasted centuries in advance. But interstellar objects arrive without warning. They come from directions we do not expect, at speeds we cannot control. They are messengers, yes, but they may also be weapons of chance, flung by the indifferent hand of the galaxy. Atlas itself posed no threat. Its trajectory was clear, its size too modest to endanger worlds. But its presence reminded us of the possibility. For every harmless wanderer, there may be another with a path less forgiving, one that intersects Earth instead of slipping past. What then? The Chicxulub impact, 66 million years ago, ended the age of dinosaurs and reshaped the course of life. That body was local, an asteroid or comet from within our solar system. But imagine the same event, delivered not by a local fragment, but by an interstellar one. Its velocity, higher than anything bound to the Sun, would amplify its energy. Even a relatively small interstellar impactor could release devastation on a planetary scale. And unlike local comets, we would have little warning. Our telescopes might detect it only months, perhaps weeks, before collision. This is not fear-mongering, it is physics. The galaxy is restless, and its debris does not respect boundaries. Atlas was proof. It is a reminder that while our sun shelters us from much, it cannot shield us from all. We are open to the dark visitors as much as to the luminous ones. There are subtler threats as well. Interstellar objects may carry not only impact energy but chemistry. What compounds lie in their ices? What unknown molecules drift in their dust? Could an alien comet scatter substances toxic to terrestrial life? The likelihood is small, but not zero. Life depends on fragile balances. A fragment from another star might not nurture, it might disrupt. Even radiation can ride such stones. Dust from Atlas, had it intersected Earth's atmosphere, might have carried isotopes unstable, glowing faintly with energies not native to our planet. Harmless in trace amounts, perhaps, but reminders that interstellar matter is not always aligned with terrestrial needs. Yet perhaps the deepest threat is not physical, but philosophical. To see an interstellar body is to confront our vulnerability. It reminds us that Earth is not a fortress. It is a small island, unshielded, drifting in a cosmic sea, alive with wanderers. We like to imagine control to chart orbits, to predict impacts, to prepare defenses. But Atlas revealed that not all visitors can be foreseen. Some come suddenly, their paths bent only slightly by the sun before fleeing again. If one day such a body aimed at Earth, what would we do? The thought unsettles, but it also motivates. Atlas has already inspired proposals for interstellar interceptors spacecraft designed to wait in readiness, to launch at a moment's notice when the next visitor is detected. Their mission would be study, but their existence could also serve defense, for in knowing there is safety. The only true danger is ignorance. Still, the shadow lingers. Not every visitor is a gift. Some may be omens, not in superstition, but in science. The galaxy is not gentle. It is generous, yes, but also indifferent. Its fragments can seed life or end it. Its stones can bring archives of chemistry or extinction. Atlas, in its harmlessness, reminded us of both truths. And so, the comet that fell apart became not only a symbol of wonder, but also a warning, a reminder that interstellar objects are not all luminous messengers, they are also dark visitors, carrying the possibility of violence written into their speed and mass. A reminder that the solar system is open, and that openness is both gift and threat. In the end, the lesson of Atlas is humility. We are not alone, not isolated, not protected. The doors of our world are open to the galaxy, and the galaxy sends what it will. Sometimes knowledge, sometimes wonder, sometimes danger. The sky, for all its beauty, carries both light and shadow. Atlas was one shadow that passed us by, but it will not be the last. Every fragment of matter carries a memory. The rocks beneath our feet tell stories of ancient oceans, vanished mountains, continents torn apart by time. So too does interstellar matter carry its own archive, a record of conditions far beyond our sun, sculpted by forces we have never touched. To study a comet like Atlas is not just to see ice and dust, it is to read a message written in a different dialect of physics, a chemistry older than our world, a script etched across interstellar distances. For scientists, the allure is simple. Each atom of Atlas was once bound to another star. Its molecules were formed in a nursery foreign to us, perhaps under the light of a blue giant or within the cold shadows of a distant nebula. Its isotopes are fingerprints, telling us where the object came from, how long it wandered, what radiation it endured. To capture such an object, to sample it, would be to hold in one's hand a shard of another history. But beyond the chemistry lies a subtler question. Could interstellar objects be signals, however unintentional? Each visitor carries ratios of elements, alignments of molecules, distributions of isotopes. Together, they form patterns that differ from our own solar system. If life exists elsewhere, these objects may carry its raw ingredients or its detritus. They may bear amino acids unfamiliar to Earth, or chains of carbon that hint at biology but are not our biology. They may hold secrets about how common or how rare life truly is. There is precedent. In meteorites that have fallen to Earth, scientists have found amino acids, sugars, and complex organic compounds. These were local messengers, fragments of asteroids that formed in our solar system. If such complexity can emerge here, what might emerge elsewhere? Imagine Atlas still intact, its nucleus hiding frozen seas of alien chemistry. What strange molecules lay beneath its dust, never warmed by our sun, never touched by terrestrial air? To analyze them would be to listen to a chemical broadcast from across the galaxy. There are darker possibilities too. A signal need not be benevolent. What if a fragment carries isotopes arranged in ways that seem deliberate, a pattern not explainable by natural processes? Would we interpret it as coincidence or as communication? Could an interstellar object serve as a carrier of knowledge, hurled across space not by chance but by design? The philosopher Arthur C. Clarke once suggested that sufficiently advanced technology would be indistinguishable from magic. Perhaps the galaxy is full of artifacts that we mistake for stones. Perhaps the next atlas will carry not just ice but machinery signals encoded in minerals, transmissions that wait to be unlocked not by radio telescopes but by microscopes and mass spectrometers. Of course, this remains speculation. No evidence yet suggests that Atlas, or any interstellar visitor, was artificial, but the possibility stirs imagination because it is testable. To capture such a body, to drill its ice, to examine its dust in detail, that is to test whether we are truly alone, and science thrives on tests that can be made. In the meantime, our signals are indirect. Telescopes watch the light scattered by these visitors, passing its spectrum. Chemical lines reveal the presence of carbon monoxide, water vapor, organic molecules. In these faint fingerprints, scientists already see hints of complexity. Not enough to prove life, but enough to deepen the mystery. Enough to remind us that every interstellar object is a broadcast, a whisper, an announcement that the galaxy is not uniform but varied, alive with strange chemistries. There is another kind of signal too, not chemical, but gravitational. The mere path of an interstellar object through our solar system is a kind of message. It reveals how the galaxy stirs its fragments, how stars scatter their remnants into interstellar exile. Atlas traced one such line across our skies, then broke apart, leaving us only fragments of its story. Yet, even in its destruction, it carried information about its structure, its fragility, the stresses of travel. Even failure was a form of signal. For the human spirit, these signals resonate deeply. They remind us that we are not isolated. The galaxy does not ignore us. It reaches into our solar system, offering fragments of its memory. The question is whether we will learn to listen. Atlas, had it lingered, might have offered more. Samples of its dust could have told us if its molecules bore the same handedness as ours, the same chirality that defines all life on Earth. A match would suggest universality. A mismatch would suggest diversity. Either way, it would have changed us, altering our understanding of what it means to be alive. But Atlas left too soon. Its signals were faint, scattered, partial. They remind us of the opportunity we lost. Yet, they also sharpen our anticipation for the next time. Because there will be a next time. The galaxy is not silent, and the signals it sends will keep coming. In the end, every interstellar object is a letter written in a language we have not yet mastered. Some letters may be fragments of poetry, telling of beauty and creation. Others may be warnings, reminders of chaos and destruction. Atlas was one such letter delivered, torn apart, and carried away before we could fully translate it. But even incomplete, it told us enough to know that the galaxy is speaking. The question is whether we are ready to hear. Gravity is not force, but shape. That was Einstein's revelation. The sun does not pull planets as if by invisible ropes. It bends the stage upon which they move. Space-time itself is warped, curved into valleys and hollows, and matter merely follows the lines of that invisible landscape. An interstellar visitor like Atlas does not enter our solar system as a trespasser on a flat stage. It falls into a bowl carved by the sun's presence, skirting along the sloped edges of space-time, its trajectory twisted not by pull but by geometry. To understand its passage is to recognize that every comet, every asteroid, every planet is not moved but guided, flowing along space-time's contours like water finding its channel. This frame explains much of what made Atlas so mysterious. Its high velocity was not arbitrary, it was a measure of the energy it carried from a different star's well. As it crossed the sun's domain, its path bent but did not bind. For only those who arrive below a certain threshold can be captured. Atlas came too fast, too heavy with the inheritance of distant gravities. It would curve, yes, but it would never stay. Astronomers traced this curvature with exquisite care. Equations derived from Einstein's general relativity described how its orbit deflected by a fraction of a degree, how light from stars behind it bent minutely as it passed, how the sun's geometry wrapped its journey. Each measurement confirmed once again that relativity was not theory alone, but law written into the cosmos itself. Yet the more one reflects, the more uncanny it becomes. Einstein's universe is not one of forces in conflict, but of shapes in constant conversation. Mass tells spacetime how to curve, spacetime tells mass how to move, and so Atlas, unbound, carried on a dialogue with the Sunday. It bent slightly, obeyed the shape, then carried the memory of that conversation outward again into the night. This dialogue is not limited to comets. It governs black holes, neutron stars, galaxies themselves. But to see it applied to a small interstellar body is to see the principle scaled down, rendered intimate. Relativity is not just the province of extreme events. It whispers through every orbit, every fall of stone, every curve of comet dust. And there is poetry in the scale. When Atlas curved around the sun, it reenacted the same law that bends starlight from galaxies billions of light years away. The same equation that describes a planet's orbit also describes the lensing arcs we see in Hubble images. The universe, vast and unfathomable, is coherent. Einstein's frame does not fracture between the small and the great. It unites them. But here lies a subtle tension. Atlas moved through spacetime as predicted, yet its very existence raised questions that relativity alone could not answer. Where did it come from? What processes expelled it from its parent star? What hidden gravities sculpted its exile? Relativity tells us how it moves, not why it was moving. It describes the curvature, not the origin. The mystery deepens, for science offers clarity at one level and silence at another. There is also the matter of extremes. If Atlas had passed nearer to the sun, it would have felt stronger curvature. Its path might have been altered enough to graze planets, to fragment differently, to change our story entirely. In the delicate mathematics of relativity, small differences in initial conditions can ripple into vast consequences. Fate is geometry, but geometry is sensitive. Some astronomers wonder whether interstellar objects can act as natural tests of relativity itself. Their velocities are so high, their orbits so open, that they provide cases rarely seen in our closed system. To measure them with precision is to check whether Einstein's equations still hold, or whether, at the edges, new physics waits. Could Atlas, had it lingered intact, have betrayed tiny deviations? Could it have whispered of modifications to gravity, of dark matter's unseen hand, of new frameworks waiting to replace the old? We do not know, but its passage renewed our awareness of the frame we live in. Gravity is not simply attraction, it is architecture. To look at the stars is to see the floor plan of the universe, drawn in curves of spacetime. To watch a comet like Atlas glide through is to glimpse how the plan extends, how foreign stones navigate the same architecture we do. For the human mind, this is both comfort and vertigo. Comfort in knowing that the same rules govern the farthest galaxy and the nearest grain of dust. Vertigo in realizing that we are caught within this frame without choice, bound to its curves, our every motion dictated by shapes too vast to see directly. Einstein once wrote that the most incomprehensible thing about the universe is that it is comprehensible. Atlas was one more proof of that paradox. Its arrival seemed improbable, chaotic, random, yet its motion was exact, calculable, inevitable. It obeyed laws written more deeply than chance. The mystery lay not in how it moved, but in why it existed to move at all. In this sense, Atlas became a mirror. It showed us the elegance of relativity, but also its limits. It reminded us that physics can explain the path, but not always the purpose, that beyond geometry, There is story one written in stellar births and deaths, in gravitational scatterings, in histories we cannot yet reconstruct. And so, even as its fragments dispersed, Atlas left us with a profound realization: the solar system is not an isolated island, but a node in a wider fabric. That fabric is not stitched with force, but with curvature. And we, like Atlas, move upon it, following lines we did not draw, carried by shapes we cannot refuse. The frame holds us all. The question is whether we can ever see beyond it. There is silence beneath silence. Physics tells us that the emptiness of space is not truly empty. It seethes with fields, with particles flickering into existence and vanishing again. Beneath the calm of the void, quantum fields hum, a restless background that defines reality itself. To walk, to breathe, to exist is to be woven into that hum. But what if the vacuum is not stable? What if the ground of reality is only temporary, a plateau perched above a deeper abyss? This is the question of the false vacuum, a concept born from quantum field theory. It suggests that the vacuum we know may not be the ultimate state of lowest energy. It may only be a local minimum, a false resting place. If disturbed, it could collapse, rolling downward into a truer vacuum. The consequences would be unthinkable. A bubble of true vacuum, once nucleated, would expand at the speed of light, rewriting the laws of physics in its path. Chemistry would vanish, atoms would dissolve, the constants that define matter and energy would change. The universe we know would end, not in fire, but in a cold, absolute rewriting. Why speak of this in the story of Atlas? Because interstellar bodies are reminders of the fragility of structures we take for granted. Atlas, like all matter, was bound together by forces defined by our vacuum. Its ice, its dust, its fragile cohesion all depended on constants born of the vacuum state. If those constants shifted, the comet would not just change, it would cease to exist. Scientists ponder whether events of unimaginable energy collisions of cosmic rays, interactions near black holes, or even high-energy particle collisions in accelerators could, in principle, trigger such a collapse. The probability appears vanishingly small, but non-zero, and in a universe that lasts long enough, even the improbable becomes inevitable. Some theorists argue that the Higgs field, the field responsible for giving mass to particles, may be metastable. It rests in a false vacuum, not truly stable, but only waiting. One fluctuation, one cosmic event of sufficient violence, could send it cascading downward. The scale of the catastrophe would make supernovae, black holes, even galactic collisions pale by comparison. This would not be the destruction of a star or a galaxy, it would be the destruction of physics itself, as we know it. Here, Atlas becomes a metaphor. It drifted into our solar system, fragile and temporary, surviving for millions of years only to break apart in the warmth of the Sunday. Its existence was not guaranteed, its stability fragile. It reminds us of our own position. We, too, may be living within a fragile plateau, stable only for a time, destined to collapse into something deeper. And yet, paradoxically, this fragility is not cause only for dread, it is also cause for wonder. The fact that our vacuum has lasted this long, that physics has remained coherent for billions of years, has allowed stars to shine, planets to form, life to emerge. Fragility has been the cradle of creation. We may not know if the vacuum is true or false, but we know that within it, consciousness has bloomed. Philosophically, the false vacuum is unsettling because it strips away the illusion of permanence. We are conditioned to think of laws as eternal. To suggest that even the bedrock of physics may be temporary is to admit that nothing is guaranteed. The very stage upon which existence unfolds may one day fold itself away. For humanity, this realization is both terrifying and liberating. Terrifying Because it leaves us powerless. No shield, no technology, no preparation could protect against a vacuum collapse. It would arrive without warning, its edge traveling at light speed, rendering futile any attempt to escape, but liberating because it reminds us that survival is not always the point. Meaning is found not in duration, but in presence. If the vacuum is unstable, then the miracle is not that it may one day end, but that it has endured long enough for us to exist at all. In the story of science, false vacuum decay is more than speculation. It is a testable idea, bound to the properties of the Higgs boson, to the masses of fundamental particles, to the shapes of potentials plotted on chalkboards and simulated in supercomputers. Each experiment at the Large Hadron Collider is not just a probe of high energy, it is a probe of reality's stability. The whispers of the vacuum may yet be translated. And so, Atlas's fleeting presence becomes a parable. A comet that fell apart reminds us of a universe that may one day do the same. Fragility is not confined to stones of ice. It may be written into the fabric of space itself. The vacuum whispers, and in its whisper is a question. Is this the true ground of being, or only a pause before the fall? For now, there is no answer, only silence beneath silence. Every horizon conceals another. When astronomers first measured the expansion of the universe, they assumed it would slow. Gravity, they thought, would tug gently at the fabric of space, drawing it back towards stillness. Instead, they found acceleration, a universe stretching faster with time, driven by an unseen energy we call dark energy. This revelation transformed cosmology. If the universe could expand forever, then beyond the edges of our sight lie realms we will never reach, regions eternally cut off. But what if the boundaries run deeper still? What if our universe is not the only one? The concept of the multiverse is not born of fantasy, but of equations. Inflation theory, which describes the universe's earliest instance, suggests that space may have expanded not once, but eternally, spawning bubble after bubble of new universes. Each bubble may carry its own constants, its own laws of physics, its own versions of matter and energy. Some may host galaxies like ours. Others may flicker into existence and vanish almost instantly. And between them stretches a cosmic ocean, vast and unmeasurable. Where then does Atlas fit in this horizon of horizons? On the surface, it is only a comet, a fragment from another star. But symbolically, it is a reminder that boundaries are porous. Our solar system is not sealed, it is open to interstellar matter. And if it is open to stars beyond our own, what of universes beyond our own? Might matter or signals slip between them, carried across invisible membranes? Might every interstellar wanderer be not just a stone, but a whisper from another cosmos entirely? Speculation, yes, but speculation tethered to science. Some cosmologists argue that the multiverse, if real, could leave imprints in our own. Collisions between bubble universes might scar the cosmic microwave background, leaving faint circular patterns in its glow. Quantum fluctuations from other regions might influence the constants we measure here. The multiverse, though unreachable, might not be undetectable. Atlas itself did not carry proof of another universe, but its arrival evoked the possibility. For if even comets cross between stars, might not larger crossings exist? The principle is the same. Isolation is an illusion. Our solar system is not alone. Why assume our universe is? The philosophical implications are vast. If the multiverse exists, then our universe is not unique. It is one chapter in an infinite library. In some universes, life may never form. In others, it may flourish in forms unimaginable. Somewhere, perhaps, another Earth spins beneath another sun, with its own histories, its own comets, its own storytellers wondering if they are alone. But the multiverse also challenges meaning. If infinite universes exist, then so does infinite variation. Every possible history may unfold somewhere. Every version of us, every choice, every outcome. Does that diminish our story, making it only one of countless echoes? Or does it exalt it, reminding us that even in infinity, this version, our version, is still ours alone? Here the presence of Atlas becomes poignant. It was a singular body, one among countless fragments scattered across the galaxy. And yet, for us, it was unique. Its path intersected ours, its story touched ours. The multiverse may contain infinite comets, infinite wanderers, infinite versions of Atlas. But only this one appeared in our skies. Only this one broke apart before our telescopes. Only this one became part of our history. Science continues to probe the edges of this possibility. Observatories scan the cosmic background for anomalies. Theories of string landscapes propose countless possible vacua, each with different physical laws. Even quantum mechanics, in some interpretations, suggests branching realities, every measurement spawning new universes of possibility. The multiverse may be speculation, but it is not fantasy, it is the extension of physics pushed to its horizon. And perhaps interstellar visitors like Atlas serve as reminders of this horizon. They show us that what seems distant can cross over, that what seems beyond can appear suddenly, without warning, leaving us transformed. A comet from another star is, in miniature, a metaphor for universes beyond our own. Both suggest that isolation is never absolute. The beyond can and does intrude. For humanity, the idea of the multiverse is both unsettling and liberating. Unsettling because it denies uniqueness, liberating because it expands possibility. If this universe ends as it must, others may continue. If life here is fragile, elsewhere it may thrive. The story is larger than we imagined, but our part in it remains real. Atlas was one fragment, one stone among countless, one whisper from beyond. But in its fleeting arc, it opened our imagination to horizons far wider. Not just the horizon of the solar system, not just the horizon of the galaxy, but the horizon of universes themselves. And so, as we watched it disintegrate, we were reminded, the story of the universe may itself be only a chapter. Beyond it lie others, still unwritten, still unseen, horizons beyond horizons. The universe wears a mask. For centuries, astronomers believed gravity was the only sculptor of cosmic destiny. It bound planets to stars, stars to galaxies, galaxies into clusters. Gravity was the thread that stitched the cosmos together. But in 1998, as scientists measured distant supernovae, they found the stitches pulling apart. The light arrived dimmer than expected, stretched more than models predicted. The universe was not slowing down, it was accelerating. Something unseen was at work. We gave it a name, dark energy, a term less of understanding than of admission. We do not know what it is, only that it exists, woven invisibly into the fabric of reality, shaping its expansion. Roughly 70% of the universe is this unknown substance. We live not in a cosmos of stars and galaxies, but in a cosmos of mystery, where the visible is only a fraction of the whole. How does Atlas connect to this veil? In a literal sense, it does not. The comet was a fragment of matter, small against the canvas of dark energy. But symbolically, its fleeting presence reminds us of the hidden forces at play. Its path was guided by gravity, yes, but the stage upon which it moved, the expanding universe, was shaped by something deeper, something concealed. Atlas was a reminder that what we see is never the whole of what is. Scientists probe dark energy through subtle measurements. They map galaxies across billions of light years, searching for the fingerprints of expansion. They watch how structures grow, how voids widen, how cosmic filaments stretch. Each data point is a clue, a partial glimpse behind the veil. Telescopes like Euclid and the Vera C. Rubin Observatory seek to chart the sky with precision, turning darkness into data. Yet the veil remains. Theories abound. Perhaps dark energy is the cosmological constant. Einstein once proposed a fixed energy of space itself, unchanging, eternal. Perhaps it is quintessence, a dynamic field that shifts with time, waxing and waning like a hidden tide. Or perhaps it is something stranger still, a sign that our understanding of gravity itself is incomplete. What does it mean, philosophically, to live in a universe ruled by something we cannot see? For humanity, it is humbling. We gaze at galaxies and think them immense, but they are the minority. We study matter and energy, but they are the exception. Most of reality is veiled, unlit, unknown. We are children in a vast house, having mapped only the smallest room. Dark energy also reshapes our future. If it remains constant, the universe will expand forever, accelerating into emptiness. Galaxies will drift apart until even their light can no longer reach us. The night sky will grow barren, stars will die, and darkness will reign. If dark energy shifts, the end could be stranger still, a big rip tearing galaxies, stars, even atoms apart. Or a reversal, collapse into a final fire. In this light, Atlas becomes a poignant metaphor, a body that drifted into view, lingered for a brief moment, and then disintegrated, a story of emergence, presence, and disappearance. So too may our universe be a fleeting arc across the larger unknown. So too may everything we know dissolve into silence, leaving only echoes across horizons we cannot cross. And yet, in that veil, there is also beauty. Dark energy reminds us that mystery is not absence, but presence. The cosmos is not empty, it is filled with something beyond comprehension. To live in such a universe is to live not in despair, but in awe, for the unknown is not a void, it is an invitation. In the end, Atlas and dark energy share a lesson. The most powerful forces are often unseen. The comet's fragments slipped back into the night, leaving only whispers of dust. Dark energy stretches the universe, unseen but irresistible, leaving only whispers in the redshift of distant light. Both remind us that what matters most may lie beyond our vision. The veil remains, but perhaps that is its purpose, not to be pierced fully, but to remind us that there is always more beyond the horizon, always another layer of mystery, always another secret waiting in the dark. Time is not the same everywhere. In the life of a human, a year is a measure of memory, birthdays, seasons, milestones. A century is already vast, stretching beyond the reach of individual experience. But in the life of a star, a century is nothing, a flicker in the burning of hydrogen. In the life of a galaxy, even millions of years can pass without notice, as stars orbit calmly, slowly, in spirals that endure for eons. Cosmic time dwarfs human time, and yet, paradoxically, human beings are the first creatures we know to be aware of both. We live briefly, but we can imagine eternities. We are fragile, but we dream in scales that eclipse galaxies. Atlas reminded us of this tension. Its journey may have lasted millions of years ejected from its home star system, drifting through interstellar night, passing unseen across light years of emptiness. By the time it arrived in our skies, entire civilizations had risen and fallen on Earth. Species had gone extinct, mountains had eroded, continents had shifted, and yet, for us, its presence lasted only weeks. Observed by telescopes, charted by astronomers, it disintegrated almost as soon as it was noticed. This contrast is profound. a journey of epochs ended in a moment, a million-year exile reduced to a fragment in human memory. It is the same with all things cosmic. Stars live for billions of years, but we see them only as points of light on a single night. Galaxies collide over hundreds of millions of years, yet in our lifetimes they appear frozen, unmoving. We are beings of seconds watching processes of eternity. Einstein taught us that time itself is relative. For Atlas, moving near the speed of escape, time stretched differently. Its atoms ticked according to its own clock, its journey unfolding across a tempo alien to us. For the universe, time is not singular but manifold, woven into the fabric of space-time, bent by gravity, stretched by expansion. Human time is not wrong, but it is partial. It is one tempo among many. Philosophically, this leaves us with a paradox. We measure our lives in decades, yet we exist inside a cosmos measured in billions of years. What, then, does significance mean? Are we less real because we are brief? Is Atlas less meaningful because it crumbled in our skies after a journey so long? Perhaps the opposite is true. Meaning is not tied to duration. The comet's fleeting passage became significant precisely because it intersected with us, precisely because it was brief. Its story mattered not for its length, but for its contact, and so too with human lives. Our brevity is not negation, it is intensity. The flame burns bright because it burns short. Cosmic time can feel indifferent. Stars do not hurry, galaxies do not pause. The universe expands without concern for our calendars, yet in that indifference lies a freedom. If we are not central, we are also not bound. We are free to shape meaning in the seconds we have, even as eternity flows around us. Scientists measure cosmic time through isotopes, through the decay of uranium, through the light of ancient galaxies stretched into red. They speak of billions of years, of epochs older than Earth itself. But even as they measure, they are human, bound by lifespans, short and fragile. Their instruments extend their reach, but their hearts remain tied to decades, to generations. The bridge between cosmic time and human time is not in the data, it is in imagination. Atlas embodied that bridge. It was a fragment of cosmic time, drifting for ages, yet it entered our narrative for only a season. It connected us to the immensity of interstellar scales, while reminding us of our brevity. It was both eternal and transient, both infinite and fragile. In art, in poetry, in philosophy, this duality has long been recognized. The Japanese haiku captures a moment, but within that moment lies eternity. The Greek tragedians wrote of fleeting lives against the backdrop of fate. The cosmic perspective is not new, it has haunted us since the first humans looked at the stars. What is new is that now, science confirms it. The scales we intuited are real, the eternity we sensed is measurable, the vastness we feared is true. And yet, if cosmic time is endless, human time is precious. It cannot be squandered. Every hour matters, not because the universe demands it, but because we do. The stars will continue burning without us. The galaxies will continue colliding. The comets will continue drifting. But meaning belongs to us, and it is shaped in the brevity of our span. Atlas's passage is already over, a memory of a moment. The universe will forget it, but we remember. We measured, we speculated, we reflected. And in that reflection, we found meaning not only in the comet, but in ourselves. Cosmic time may be endless. Human time may be brief. But in the union of the two, in the moment when the eternal brushes against the fleeting, there is wonder. And perhaps that wonder is what time is truly for. There is always a boundary to sight. Even with the most powerful telescopes, even with detectors tuned to the faintest whispers of light, there comes a point where the signal dissolves into noise. Beyond that point, we cannot see. The universe remains, but our instruments falter. Atlas reminded us of this boundary. Detected only in December of 2019, months before its disintegration, it had already been drifting toward us for millions of years. The technology that revealed it was advanced automated surveys, sensitive detectors sweeping the night sky. Yet the comet was nearly invisible until it was close. How many others passed unseen? How many wanderers crossed the solar system without leaving a trace in our records? The edge of observation is not just technical, it is philosophical. To know that there are things we cannot see is to admit our partiality, our incompleteness. The universe is not given in full, it is revealed only in fragments, in glimpses caught before they vanish. Atlas was one such glimpse, a reminder that discovery is always constrained by thresholds we cannot yet surpass. Astronomy has always pushed against those limits. Galileo's telescope revealed moons orbiting Jupiter, shattering old world views. Hubble's mirror revealed galaxies by the tens of thousands, expanding our sense of scale. Modern observatories James Webb, Vera C. Rubin, Euclid extend our sight deeper, wider, sharper. Yet even these marvels cannot see everything. Dust hides, distance dims, time delays. The cosmos keeps secrets. And yet, paradoxically, the edge of observation is as important as what lies within. Boundaries define wonder. To see everything would be to lose mystery. The horizon is not failure, it is invitation. It calls us forward, asking us to look again, to refine, to imagine. Scientifically, the limits are clear. We cannot track every faint object crossing the solar system. Our surveys catch the large, the bright, the fortunate. Smaller bodies pass unseen, their paths unmeasured, their stories untold. Statistically, we know they exist in vast numbers. Individually, we remain blind. Atlas was one of the lucky few that crossed the threshold of detection before its end. The same is true on cosmic scales. The observable universe is bounded by the speed of light and the age of expansion. Beyond 46 billion light-years, we cannot see, not because nothing lies there, but because time has not yet allowed its light to reach us. A hard horizon surrounds us, unbreakable, absolute. We live inside a bubble of visibility, surrounded by a darkness we cannot penetrate. Philosophically, this is profound. Human beings are finite creatures. We long for completeness, yet we are bounded. The universe allows us glimpses, never totality. The mystery is not flaw, it is essence. To exist is to live inside horizons, to know that what we see is never all. Atlas's story illustrates this. For weeks it brightened, telescopes caught its spectra, scientists modeled its orbit, and then it fragmented. Observation ended. We know only part of its tale. Its deeper chemistry remains unmeasured, its origin uncertain, its ultimate fragments unseen. Its story is incomplete, like so many stories in the cosmos. But incompleteness does not diminish meaning. The fragment we did see mattered. The data we did gather transformed understanding. The questions it left behind inspire future searches. This is the paradox of the edge of observation. Limits do not end inquiry, they sustain it. Instruments extend human senses. Telescopes stretch our vision. Spectrographs extend our hearing. Detectors translate invisible rays into visible patterns. Yet for all this extension, we remain bound to thresholds. The unknown expands with every discovery. The more we see, the more we realize how much lies beyond. There is beauty in this humility. To live at the edge of observation is to live at the edge of wonder. Our ignorance is not failure, but possibility. Atlas passed into our sight only briefly, but its very brevity made it luminous. It was proof that the universe still contains surprises, that the horizon still hides secrets waiting to be revealed. The edge of observation is not static. It shifts as technology grows. Tomorrow's telescopes will reveal what today's cannot. Tomorrow's instruments will catch what today's missed. But the horizon will never vanish. There will always be more beyond. Always new atlases wandering unseen. Always new mysteries just outside our reach. In the end, this edge is part of our story. To be human is to stand at the boundary of the known, to look outward into the unknown, to accept incompleteness as the shape of existence. Atlas was a messenger from beyond that boundary. It reminded us that observation is always partial, always fleeting, but always enough to change us. We live inside horizons, but within those horizons, we find wonder. Every stone carries a recipe. The dust of Earth holds iron, silicon, carbon, oxygen, the ingredients of mountains and oceans, bodies and breath. Yet each element also tells a story of origin, forged in the cores of stars, scattered by supernovae, gathered into planets. Chemistry is not only composition, it is memory. So too with interstellar comets. Objects like Atlas are archives of alien chemistry, fragments from stars not our own. Their ices, their dust, their isotopes preserve conditions of birth beyond the solar system. To study them is to taste the flavors of other kitchens, to see whether the recipes of creation differ or whether the cosmos cooks in universal patterns. Spectroscopy gives us the first clues. Light scattered from a comet's coma carries fingerprints of its molecules. Astronomers have found carbon monoxide, hydrogen cyanide, water vapor, and simple organics in such visitors. These are not exotic chemicals, they are familiar, foundational. But their ratios, their abundances, their isotopic quirks reveal differences. One interstellar comet might hold more carbon monoxide than any local counterpart. Another might show odd distributions of heavy hydrogen, deuterium, suggesting formation in colder nurseries. Each deviation is a whisper. I was born elsewhere. I am not from here. For life, these whispers matter. Earth's earliest molecules may have arrived on comets. Amino acids have been found in meteorites. Sugars, too. If interstellar bodies carry similar or stranger molecules, then the seeds of biology may not be limited to one system. They may drift everywhere, scattered like pollen across the galaxy. This is panspermia not as deliberate act, but as natural consequence. Life's chemistry may be not local but galactic. Atlas itself broke apart too quickly for deep analysis, but its fragments may have carried organics, complex carbon chains, that could have seeded worlds if they fell upon them. Perhaps they did, in ancient times, upon some distant planet we will never know. Perhaps, even now, its dust drifts invisibly across the solar system, carrying fragments of alien recipes that will never reach our laboratories. There is both wonder and humility in this. We think of Earth as cradle of life, but it may be more like one garden among many. The soil itself may be enriched by alien deliveries, by chemistry that traveled light years before planting roots in terrestrial oceans. If so, then our biology is already interstellar. We are not only of Earth, we are of the galaxy. But alien chemistry raises another question: sameness or difference? If life elsewhere follows the same molecules, then biology may be universal. DNA may not be unique, but inevitable. If, however, alien chemistry reveals structures unrecognizable, proteins built from different scaffolds, chirality reversed, elements rearranged, then life may be infinitely diverse. The question is not only whether we are alone, but whether we are understandable to others. Philosophically, chemistry forces us to reflect on identity. Molecules are small, interchangeable. A carbon atom here is the same as a carbon atom in another galaxy. And yet, from sameness arises difference. One arrangement yields a mountain, another a rose, another a thought. Alien chemistry reminds us that identity is fragile, not in atoms themselves, but in their patterns. We are patterns, not materials. What patterns lie hidden in Atlas's dust? What thoughts, what lives, might have arisen had its recipe been scattered elsewhere? Scientists dream of capturing the next interstellar object. Missions have been proposed, interceptors that could launch quickly, rendezvous, and sample. To scoop alien dust would be to read an ancient book, a diary of conditions from another star. We may not yet know the language, but the letters are familiar. Hydrogen, carbon, oxygen. It is the syntax, the grammar of molecules, that tells the story. And there is poetry in that. For every comet is a sentence written by a star. Every molecule is a word shaped by temperature, pressure, radiation. To study alien chemistry is to learn another dialect of the universe. It is to listen for accents in the common tongue of matter. Yet, even without full samples, the philosophical message is clear. Atlas carried chemistry, not ours. It carried a story older than Earth, older than humanity, written in ice and dust. Its passage reminds us that the universe is not only vast in space, but varied in recipe. The familiar is not uniform, the alien may be close. And so, Atlas becomes once more a mirror. In its chemistry, we see both our kinship and our difference. We see the possibility that life may be universal, and the possibility that it may be unique. We see ourselves, fragile patterns of molecules, wondering what other patterns drift unseen across the stars. Alien chemistry, familiar questions. Where did we come from? Are we alone? What does it mean to exist? Atlas did not answer them, but it asked them more clearly, more urgently than before. And sometimes, the power of a mystery is not in its solution, but in the way it sharpens the question. For much of history, humans believed the cosmos was a place of order. The stars wheeled with perfect regularity. The planets traced predictable paths. Even comets, once feared as omens, were eventually shown by Newton to obey laws of gravity, their long ellipses calculable with precision. It seemed that certainty had triumphed. With enough data, with enough mathematics, the future could be predicted, the past reconstructed. But the 20th century shattered that illusion. Quantum mechanics revealed indeterminacy at the smallest scales. Chaos theory showed that even simple systems could spiral into unpredictability when initial conditions were uncertain. The more science progressed, the more it admitted humility. Certainty gave way to probability. Determinism gave way to complexity. Atlas embodied this end of certainty. Its discovery was sudden, its path fleeting. We calculated its orbit, yes, but its disintegration was less predictable. The comet broke apart unexpectedly, its nucleus fragile, its cohesion weaker than models assumed. Predictions faltered, data corrected them. The comet was reminder. Knowledge is never final, only provisional. Even its origin remains uncertain. Simulations suggest interstellar comets are ejected during the birth of planetary systems. But from which star did Atlas come? What encounter flung it into exile? No calculation can yet tell us. Its trajectory, traced backward, dissolves into the blur of galactic motions. Somewhere among billions of stars, its home exists. But which? The answer is hidden, perhaps forever. Science thrives in this uncertainty. It does not despair when certainty ends. Instead, it refines models, sharpens probabilities, acknowledges limits. The collapse of certainty is not defeat but maturity. It is the recognition that the universe is not a clockwork, but a symphony structured, yes, but with movements we cannot yet anticipate. Philosophically, the end of certainty is unsettling. Humans long for permanence, for fixed answers, for final truths. To admit uncertainty feels like standing on shifting ground. Yet it is also liberating. Certainty confines, uncertainty opens. If knowledge is provisional, then wonder remains alive. If the universe cannot be fully predicted, then mystery endures. Atlas, fleeting and fragile, reminded us of that endurance. It defied expectations, fragmented unpredictably, carried questions we cannot yet resolve. Its story is incomplete, but perhaps that incompleteness is the point. Certainty is an illusion. Becoming, flux, change, these are reality. In the wider cosmos, the end of certainty reaches further. Dark energy resists explanation. Quantum gravity remains unsolved. The origin of the universe, the nature of time, the fate of existence, all are uncertain. We know enough to ask questions, not enough to answer them. Yet in that uncertainty, humanity flourishes. We build telescopes to push horizons, colliders to probe particles, simulations to model galaxies. Each discovery answers something, but opens more. Certainty retreats, but knowledge advances. Mystery deepens, but so too does meaning. For human life, this truth resonates. We too live without certainty. Futures unfold unpredictably. Choices ripple beyond control. We long for guarantees, but we are given only probabilities. Like Atlas, we are fragile, paths bending under forces we cannot master, fates dissolving unexpectedly. To live is to live at the end of certainty. And yet, perhaps meaning does not require certainty. Perhaps it requires only presence. Atlas was present for a moment, and it changed us. So too with human lives. Certainty may be impossible, but significance is not. The end of certainty, then, is not the end of science or philosophy. It is their beginning. It invites us to humility, to curiosity, to awe. It reminds us that knowledge is not a destination but a journey, that truth is not fixed but unfolding. Atlas, in its brief arc, whispered this lesson. Certainty crumbled with its nucleus. What remained was wonder. Every journey ends. For Atlas, the end came swiftly, its fragile body breaking apart as it neared the sun, fragments dissolving into dust and gas. But in its brief life within our skies, it mirrored the fate of all things. Stars end, galaxies fade, even the universe itself carries within it a final horizon. Physicists call it the heat death, a state not of fire, but of stillness. As the universe expands, stars burn out, black holes evaporate, energy dissipates. Entropy rises until there are no gradients left to power motion, no structures left to sustain complexity. The cosmos cools toward uniformity, a vast equilibrium where nothing happens because nothing can. This is the last horizon, not a boundary in space, but in time. A future where even time itself loses meaning, because change, the measure of time, has ceased. The seeds of this horizon are visible now. Dark energy drives expansion faster each day. Galaxies recede beyond visibility. Already, light from distant realms can no longer reach us. Our observable universe shrinks even as the universe itself grows. The night sky of the far future will not resemble ours. It will be emptier, lonelier, starless. What role do wanderers like Atlas play in this fate? On one level, none. They are small against cosmic scales. Yet symbolically, they embody it. Atlas drifted for millions of years, only to disintegrate in a moment. So too with galaxies and universes. Longevity does not prevent dissolution. Scale does not prevent entropy. The last horizon awaits all. And yet, the concept is not simple annihilation. Heat death is silence, not violence. A dissolution not by destruction but by exhaustion. The universe does not collapse in fire, it fades in whisper. In this sense, the end mirrors Atlas itself, not an explosion, but a quiet unraveling. Philosophically, the last horizon forces us into paradox. On one hand, It strips meaning. If all structures vanish, if all life ends, what is significance? What purpose does creation hold if it dissolves into silence? On the other hand, it bestows urgency. If existence is temporary, then every moment is precious. Meaning is not diminished by endings, it is sharpened. Atlas embodied this paradox. Its life in our skies was short, but meaningful because of that brevity. Its story mattered because it ended. Without ending, there is no poignancy. Without impermanence, there is no wonder. The last horizon also reminds us of humility. We often speak of permanence of legacies, civilizations, galaxies. But permanence is illusion. Even universes end. To grasp this is not despair, but awakening. It reminds us that value is not in survival, but in being. The last horizon will come, but we are here now. Some physicists speculate alternative endings. A big rip, where expansion tears all apart. A big crunch, where gravity reverses the flow. A bounce, where universes collapse and birth anew. Each theory paints a different horizon, but all share the truth. Endings define stories. The universe, like Atlas, is narrative. Its beauty is inseparable from its finitude. There is also mystery. Could the last horizon itself be only a horizon? Could entropy's silence give rise to new structures, new fluctuations, new beginnings? Physics hints at cycles, at quantum fluctuations birthing new spacetimes, at bounces hidden beyond collapse. If so, the last horizon may be only another gateway, just as Atlas ended here, but its dust continues elsewhere. For humanity, the last horizon is distant beyond comprehension, trillions of years, perhaps more. Yet we reflect on it now because it reveals who we are. Fragile beings on a fragile world, aware not only of our mortality but of the universe's. We carry within us the knowledge of endings far larger than ourselves. That awareness is both burden and gift. In this sense, to contemplate the last horizon is to complete the arc of wonder. We began with a comet, a small visitor from beyond. We end with the fate of all reality. The scale has widened, but the lesson is the same. Nothing lasts forever, but everything matters. Atlas was a messenger of transience. So too is the cosmos. And perhaps, in acknowledging the last horizon, we find not despair, but reverence. For existence is not measured by eternity, it is measured by presence, by beauty, by meaning glimpsed before silence. The last horizon waits, but until it arrives, the universe sings. In the end, Atlas was only a comet, a fragile body of ice and dust, drifting between stars, pulled briefly into the embrace of our sun before breaking apart. It left no monument, no permanent trace in the heavens. Its fragments dissolved into silence, carried away by solar winds. And yet, for us, it became a mirror. We saw in it the story of ourselves, a long journey through darkness, a brief moment of brightness, an end that seemed premature but was inevitable. Atlas was not just a celestial visitor, it was a metaphor for existence itself. We often think of permanence as the measure of meaning. Civilizations strive to leave monuments, to carve legacies in stone, to be remembered beyond death. But Atlas reminded us that transience does not negate significance. Meaning is not in how long something lasts, but in how deeply it touches while it is here. The comet's life in our skies was measured in weeks, yet it reshaped our understanding, deepened our wonder, sharpened our questions. That was enough. So too with human lives. We are brief against cosmic time, fragile against cosmic forces, yet in our brevity lies intensity, in our fragility lies beauty. We are like comets, each carrying a unique chemistry, a pattern of molecules, a story written in atoms. We cross the universe, touch others for a time, then fade. But in that touch, in that fleeting brightness, meaning blooms. Atlas also reminded us of humility. The universe is vast, governed by forces we barely comprehend. Dark energy stretches space itself. Quantum fields whisper of instability. Multiverses may lie beyond horizons. The cosmos is larger, stranger, more mysterious than we can ever fully grasp. Yet we are part of it. We are not outside, looking in. We are inside, woven from the same dust, moved by the same laws, destined for the same ending. There is awe in that recognition, to know we are small, yet conscious, to know we are temporary, yet able to contemplate eternity, to know we are fragile, yet capable of wonder. Perhaps this is our role, not to control the cosmos, but to witness it, not to master mystery, but to honor it. Atlas came and went, and the universe continued. Stars burned, galaxies turned, space expanded. On the cosmic scale, its passage was nothing. Yet for us, it was everything, because it was ours to see. The comet was not diminished by its insignificance. It was exalted by our attention. Meaning is not given by the universe. It is created in the act of noticing. And so, as we look forward, we remember that other atlases will come, other visitors from beyond, each carrying secrets of chemistry, whispers of origins, questions of destiny. We may be ready next time, ready with spacecraft, ready with instruments, ready to catch what was lost before. But even if we are not, the lesson remains. Every glimpse is precious. Every mystery is gift. In contemplating Atlas, we also contemplated ourselves. What if we, too, are wanderers? What if Earth is not a cradle but a comet, drifting through time, destined to dissolve into silence? If so, then our task is not to deny it, but to live within it, to make our brief arc luminous, to leave behind fragments of meaning, even if they too dissolve. The comet disintegrated, but its story did not. It lingers in data, in memory, in reflection. It lingers here, in words, in the silence that follows them. That is what humans do. We turn fleeting phenomena into lasting meaning. We weave ephemerality into narrative. We turn dust into poetry. And in that act, perhaps we find our true place in the cosmos, not as masters, not as survivors, but as storytellers, witnesses of mystery, translators of silence, bearers of awe. Atlas is gone. The universe continues. One day, so will we. But until then, we are here, watching, wondering, weaving meaning from the fragments the cosmos gives us. And perhaps that is enough. For to live, to see, to wonder, that is the brightest arc of all.